Hello everyone, if you are completely new to Unreal Engine 5, then this tutorial was made for you. In this tutorial, you will go from knowing nothing about Unreal Engine 5 to creating this beautiful world you see right here. Now, I know this might look intimidating, but do not worry. Every step in this process, from sculpting the landscape to creating the castle, will be shown in detail. This video is pretty long, but that's because Unreal Engine 5 is a big program, and we have a lot to cover. To help navigate this video, I divided it up into individual chapters. You can find links to all the chapters in the description below. In this tutorial, you will learn how to install Unreal Engine 5 and create a project, how to navigate and move objects in your 3D world, create materials and import 3D models, go over Unreal's amazing new dynamic lighting system called Lumen, sculpt landscapes and paint foliage, download free Nanite objects from the Megascan's library, and finally we will briefly go over how to program a game using blueprints, and at the end, create the fantasy environment you see right here. I know learning Unreal Engine 5 can be tough at first, which is why each chapter in this video can be treated as its own self-contained lesson. So if you're ever stuck on something, you can always go back in the video and re-watch that chapter. Also, all the assets I use in this video are completely free, so you can follow along with me. Now, with all that being said, let's jump into UE5. To begin, before we can use Unreal Engine 5, of course we have to download Unreal Engine 5. To do so, you need the Epic Games Launcher. You can get it from their website, and come all the way down here to the Unreal Engine tab. Now, with the tabs up here, you want to click on Library, and if you don't see Unreal Engine 5, then you don't have it downloaded. To download it, you want to click on the plus icon next to Engine Versions, and make sure you have 5 selected, and then click on Install. Now, it's going to ask for an install location. You can just leave it at the default place, but if you do want to bring it somewhere else, then you can click on Browse and select a new location. But I'm just going to leave it default and click Install. Once Unreal Engine 5 is done downloading, all you have to do to open up is to click Launch, or you could click Launch up here, but Unreal Engine 5 isn't set as the default engine. You can set it as the default engine by clicking on the dropdown and selecting Unreal Engine 5. Alternatively, if you don't want to go through the Epic Games Launcher, you can click on the dropdown right here and create a shortcut on your desktop. Now that shortcut has been created, let's open up Unreal Engine 5 by just double clicking on the application. The Unreal Project Browser will pop up when you open up Unreal Engine. Essentially, this is where we open up recent projects, or we create a project completely from scratch, which is what we're going to be doing. Now, you can create your project from a template, which essentially is a pre-made project to help point you in the right direction with a lot of stuff already done for you. For example, if you're in the car industry and you want to render out a car, then possibly going into the Automotive tab and selecting Photo Studio will be a good template from where you will start. But for our cases, I want to start from complete scratch. So I'm going to come to Games and make sure I select blank. Now down here is the project location where our project is going to be saved. I just want to save this on the desktop. If you do want to save it somewhere else, then you can click on the file icon right here and browse to a different folder. Now right here is the project name. So let's call this one First Project. And up here are some project settings. Now I'm going to leave it at Blueprint since we're not going to be going over C++ coding in this video. And down here, I want to make sure starter content is enabled. Starter content will give us some nice assets that we can play with to help us learn Unreal Engine 5. Below that is ray tracing. We're not going to go over ray tracing just yet. And of course, to create this project, let's click on Create. So this is what you should see when opening up Unreal Engine for the first time. Don't worry, we're going to go over what all these different windows and buttons do in just a second. But before that, I want to go over how Unreal Engine stores projects. So let's exit out of this project, and we can see that a brand new folder was created on our desktop. Remember, I selected my desktop as the place to save our project. Essentially, this folder contains all the data that makes up our project. So whenever we make a change in our project or we create something in the project, it's going to be stored right here. Now to open up our project again, all you have to do is double click on the .u project asset right there. And that will open up your project from where you last saved it. To begin, let's briefly go over how to navigate the user interface and what all these different windows do. So probably the window that sticks out the most is the viewport right here. The viewport is essentially just a view into our 3D world that we're creating. So for example, we can fly around and look at our world. We can even grab objects and manipulate them all within the 3D viewport. Now, don't worry, we are going to go over camera controls and how to move objects in just a bit. But I first want to go over what the different windows do. Right above the viewport is the toolbar. The toolbar is pretty important because it's where we get a lot of our tools and a lot of different buttons we're going to be continually pressing. For example, what if I want to add an object into our world? Then I can click on the plus icon and scroll down to shapes, and maybe I add in a sphere and place it in the world to move it around. I can also switch modes. So right now I'm in select mode, which is the main mode where we can move objects around. Let's say if I'm making a landscape, I can go into landscaping mode and create a landscape. Or I can go into foliage mode and start to paint foliage if I do have those assets. If you are curious, we are going to go over both modes later in the video. Now to the right of that, we have the outliner. The outliner is essentially a list of all the objects that make up my current world. So for example, if I want to select a chair, but the chair isn't in my view right now within the outliner, I can select the chair right there like that. I can also select multiple objects by holding down Control. So maybe I want to select both chairs, just hold down Control like that, and maybe also the statue right there. The outliner is also a great place to organize your world. For example, we have all these folders. Real quickly, if you want to create a folder, all you have to do is right click, create folder. Let's call this one My Folder, and holding down Control, let's select both chairs and simply drag them into there just like this. We can also hide and unhide objects. For example, maybe I want to edit something that's behind the table, but the table's in the way right now. I can come here and temporarily click on the eye icon to hide the table, and then click on the eye icon again to unhide it. And right below the world outliner, we have the details panel. The details panel is essentially where we can edit all the properties of an object that we have selected. For example, maybe if I don't like the scale of this chair right here, I can select the chair and come to scale and maybe increase it by 2 in the Z axis, which is the vertical axis, and see that we have a really long and tall chair. Now, I don't like that edit. It looks kind of weird. So you can always press Ctrl and Z in Unreal Engine to undo anything. Now, we do have one more default window. That's arguably the most important window since it stores everything we're doing. It stores information on the chairs, the table, even the entire world. And that is the content drawer. You can get the content drawer by going all the way down here to the bottom left-hand corner and clicking on content drawer like that to bring it up. Alternatively, since this window is pretty important, you can press Ctrl and space at the same time to bring it up and close it. So if you press Ctrl and space, it's going to bring up the content drawer, and this gives us a folder view of all the assets that make up our project. So for example, if we want to see where this chair is being stored and maybe we want to edit the chair, then we can come under starter content, props, and right there we have SM_chair. If I double click on it, we can see the chair asset and make any adjustments if we do need to. Now we're going to go over the static mesh editor later. So I can exit out of this window by clicking on the X icon. I'm going to press Ctrl and space again to bring back my content drawer. And probably the best example I have for the content drawer is that it's like your computer's file explorer. So just like on your computer where you have folders, and in those folders you have subfolders, and those subfolders contain assets like text files or Word documents, same exact thing with the content drawer in Unreal. So you have folders, and in those folders you have subfolders, and finally you have all those assets that make up your project. So for example, here we have the starter content folder, and I can go into it by double clicking like this, or I can click on it right here within the folder window. Now I could go into any of these different folders. For example, the maps folder contains the map we're currently editing. So we can see up here that this map is called minimal_default. Right there's minimal_default. We can double check that we are editing this map by double clicking on it to open it up. Let's go save. And we can see that it did open up the exact same map. Now, if I ever want to go up a folder, I can always click on here. So right now we're in the maps folder. If I want to get out of that, I can click on starter content. And if I want to get out of that, we can even go to content right there. Now, don't worry, if you don't have starter content, you can click on add and then add feature or content pack, and then go to content and simply select starter content and add a project. I'm not going to do that since we did add it when we were creating our project. As you can guess, the content drawer is a pretty big deal. And maybe you don't want to press Ctrl and space all the time to bring it up. You always want it docked in your layout. Well, all you have to do is click on docked in layout like this. And now your content drawer will be right here at the bottom. And notice how it's called content browser right now, not called content drawer. So whenever I say content browser and content drawer, just know that I'm talking about the same exact thing. Now, this is great, but this tab right here is taking up a little bit of real estate. If you ever want to get rid of a tab, all you have to do is right click and click on hide tabs. If you want to get back that tab, then you can click on the very small blue triangle and that will bring back your tab. Also, tabs are great because if you left mouse button and hold, you're able to move this around and dock it somewhere else. So maybe if I don't want content browser at the bottom right here, I can dock it to the side, or I can even dock it to one of the tabs right here. And now I'm able to switch in between details and the content browser. Also, if you ever want to move windows around, you can hover in between the windows and then you're able to move it down just like this to adjust exactly how you want your user interface. Now, another neat trick is that if I dock my content browser right here, and let's go make it a little bit smaller, and maybe I don't want it always visible, I can right click and go dock to sidebar. Now, whenever I want my content browser or any other window, I can just click right here and it will show. Now, if I don't want to dock to sidebar, I can right click and unlock from sidebar just like that. Now I'm going to click on the X icon to get rid of that content browser. Alternatively, if I want to automatically dock all my windows in a sidebar except the viewport, I can click on F10, which will go into full screen mode. And now we can see that my outliner and details window and any other windows I have on the side will go into docked mode. And then I can click on F10 again to bring those windows back. So F10 is a neat shortcut to automatically dock all your windows. Now, these are just the default windows. If you want to see all the windows that are available to us, we can come up to Windows and select any of these. Now, one window that we are going to be using a lot is the World Settings. So World Settings, as you can guess, just has a bunch of different properties and settings that we can play with to edit the map we currently have opened. Now, for example, what if we really mess up our user interface? It's basically unreadable. We have no idea what is happening. Don't worry, we can always come up to Window and all the way down here, go to Load Layout and click on Default Editor Layout, which will just reset all of our windows. Now that we have the very basics of the user interface out of the way, we can move on to the fun stuff, and that is camera navigation. So how to navigate our camera around our 3D world so we can view it at all different angles. To navigate is actually easier than you think. So you want your cursor inside the viewport, and then you want to hold down the right mouse button. If you now move your mouse with the right mouse button held down, you are able to look around your scene. And still, with the right mouse button held down, you're able to use the WASD keys to move around. You can also use E and Q to go up and down. So that's E to go up, Q to go down, W to move forward, S to move backwards, and A and D to move left and right, all the while holding down the right mouse button. If you are not holding down the right mouse button and you try to use WASD, then nothing will happen. So make sure you do hold that down. Now we can also control our camera speed. So let's say, for example, there's an object that's really far away and you want to go towards that object, but your camera is moving too slow. Well, if you come up here to the top right-hand corner and select the camera icon, you're now able to control that speed. So right now we're at 4. We can also bring this up to 6. And now we are a lot faster. And we can bring this all the way down to 1. And we can see that we are pretty slow. So let's leave it at 4. And a shortcut to access camera speed is to, of course, hold down the right mouse button and use the scroll wheel. So scroll wheel up will move faster, and scroll wheel down will move slower. So that's a shortcut. That's how you don't have to come up here and continually play with the camera speed if you do want to move faster or slower. Here's a really good tip. Let's say if you scroll really far away, so you fly really far away from where the bulk of your geometry, where your world is, and then you look around and you can't find your objects anymore. What you can do is come up to any of the objects right here. Let's say, for example, the chair, select that, and then press the F key to focus on that object. So if you select an object, you can press F to then snap to that object, just like this. So that's how you're never lost in your world. So if you ever played any first-person games, you should be right at home since the muscle memory is there for the WASD keys and rotating your camera by moving your mouse. Now, if we press F again to then zoom in onto an object, we can rotate around that object by holding down Alt and the left mouse button. So Alt and left mouse button allows us to rotate around a pivot object. And if we hold down Alt and hold down the right mouse button, we can zoom in and out. So right mouse button, zoom in and out, left mouse button to pivot around that object. And to focus on an object, of course, we want to select it and press the F key just like beforehand. Before we move on, let's briefly go over the viewport controls. So we know the different ways that we can view our world. So up here we have perspective. Let's say if you want a top-down bird's eye view, then we could click on the perspective button and select top like this. So to control in an orthographic view mode, you want to hold down the right mouse button to pan, and of course use a scroll wheel to zoom in and out. So right mouse button pan scroll wheel to zoom in and out. We can also view it from the side, like maybe the left side, same controls. And of course, if we want to go back into perspective, we come up here, select the button, and click on perspective. Notice how a lot of the buttons in Unreal have a shortcut right next to it. For example, perspective shortcut is Alt and G. So instead of coming all the way up here and selecting perspective in the dropdown, I can just press the Alt and G key at the same time to go back into perspective. So right next to perspective is our view modes. So view modes are pretty great because they allow us to see our world in different ways. For example, maybe we don't want to see all the lights and we just want to see the colors of our world. Instead of coming up to lit, I can select unlit right there, or I can even select wireframe to see our world's edges and vertices. We will be changing our view modes a lot since it's a great way to debug our scene and see if there's anything wrong. So I'm going to come back up here to lit, or the shortcuts are Alt-4 for lit, Alt-3 for unlit, and Alt-2 for wireframe. So let's jump back with Alt and 4 to get our default view. And right next to our view modes is the show flags. So show flags allow us to turn on and off different object types. For example, what if I don't want this grid right here at the bottom? Then I can come to show, let's go find where grid is, and uncheck that to hide the grid. Now maybe for some reason you don't want to show our static meshes, and essentially static meshes are all the objects you see right here. Then within the show flags, we can uncheck static meshes, and we no longer see those static meshes. Now, obviously we don't want that, and if you ever mess up your show flags, you can bring back the default flags by clicking on Use Defaults. And keep in mind that we aren't deleting anything with show flags, they just help us see what we want in the viewport. And finally, this is my favorite viewport option, and that is Game View. So if we come up here and click on the button with the 3 lines, we have Game View all the way down here, and we can see that the shortcut is G. Now, if I enable Game View, we're going to see exactly what the player will see in game. So if I press G to untoggle Game View, we can see that we have all these different widgets, and we have the grid right here. And of course, the player won't see the sun widget right here, which controls the sun's rotation. Instead, if we want to see exactly what the game will see, we click on G to hide all those widgets and features that are here for us, the editor. So just know that throughout this tutorial, when you see a bunch of widgets and these widgets just disappear, that's because I toggled on Game View with the G key. Now that we know how to navigate around our world, it's time to go over how to create new objects and move them around. So we're going to go over moving, scaling, and rotating objects. To begin, let's go over simple movement. I'm going to press a G key to get rid of our editor widgets. And now all we see is our world. So to move an object, simply select it. And by default, we get the translation or the movement gizmo. To move an object, hover over any of these arrows and hold down the left mouse button. So I'm able to move this chair around, but notice how moving the chair isn't smooth. That's because by default, snapping is turned on. Now you could turn off snapping by coming up here and unchecking the grid icon like that. So now we can smoothly move our objects around. Now I'm going to turn it back on because it's important to know that Unreal uses centimeters. So right now, since there's a 10 right next to the icon, it's snapping every 10 centimeters. We can change this by selecting the number, and in the dropdown, let's select 100. So now it's moving every 100 centimeters, which is 1 meter. So every time this chair moves, it moves 1 meter. So that's pretty important to know. Now I'm going to uncheck it because I do want smooth movement. Next up is rotation. So to rotate your object, you want to change its gizmo. To change a gizmo, you want to select one of the buttons up here. So right now it's on translation. Right next to it is rotation. Now I can rotate this chair in all these different axes. We can see that rotation snapping is turned on. If I want to turn that off, then right next to translation snapping, we have this icon right here. Make sure it's not blue. And now we're no longer snapping every 10 degrees. I can press Ctrl Z to undo all those changes. And let's go over scaling. So right next to rotation, we have scaling. And scaling works pretty similar to the rest of the gizmos. All you have to do is hover over any of these squares, hold down the left mouse button, and now we're going to scale in that exact direction. So if we want to turn off scale snapping, of course, just uncheck the icon right there, and now we can smoothly scale. I'll press Ctrl Z a bit because it's important to point out that if I hover my mouse not over one of the individual squares, but the one square that's connecting all of them, so the one in the middle, hold down the left mouse button, I can move my chair and scale it uniformly up and down. So not in any particular axis. So I press Ctrl Z to undo all those. And if we hover over all these buttons, we see that there's shortcuts. So movement is W, rotation is E, and scaling is R. So that means it's W to move, E to rotate, and R to scale. So those are some of the most common shortcuts that we're going to be using consistently throughout our time in Unreal Engine. So again, one last time, it is W to move, E to rotate, and R to scale. I also want to point out that if we want to move our object in the direction of our object, then come up to this little globe icon, select it. That's how it's now a square. And we can see that we're now able to move the object in that object's direction. So move it locally instead of globally. If we want to switch it back to global, then click the square icon again to make it a globe. And now we're moving it in the direction of the world and not that individual object. It's also important to point out that if I press W to get our translation widget, and if I hover over the square that's in between the different axes, I'm able to lock it and move it only in those two axes. So if I hover in between the Y and X axis, I'm just moving it in between those and not in the Z axis. I can also lock it in between the Z and Y axis, just like this. So let's press Ctrl and Z to undo those changes. Now you're probably wondering, how do we create an object in our world? Well, there's a couple ways. Number one is that we can duplicate an object. So with any object selected, for example, this statue, if I press Ctrl and D, then we just duplicate that object. Now, we didn't notice a change. That's because it duplicated it in the same spot as the original object. So if I hold down the left mouse button and move it out of the way, we can see that we did duplicate that object. And within the outliner, there's now a new object called Statue 2, which is a copy of the original statue. So let's delete Statue 2. And there is an easier way to duplicate. And this is the way I duplicate. And that is hovering over an arrow with a translation widget selected and holding down Alt and left mouse button. So hold down both of those and simply drag. And now we're able to easily duplicate and drag an object away. So let's press Ctrl Z to undo all those changes. Now, another way to create an object is by using the Add tool up here in the toolbar. So for example, let's click on Add and let's come all the way down here to Shapes, and maybe we want to drag in a sphere. So we drag it in like this, or we can even add in a light, like a point light, and we're able to drag it around in our scene. So let's go delete those. And finally, the last way to add an object is through the content browser. So let's bring up the browser by holding down Control and Space at the same time, pressing both of those. And let's go into props. And to add an object into the content browser, hold down the left mouse button and drag it into your world. For example, this couch. So let's go move it down just like this. And now we have a brand new object. So by holding down Shift, you can select multiple objects. So for example, if I have my chair on the left selected, and I want to select the chair on the right, if I hold down Shift, now I have them both selected. If I hold down Shift again, I can add in the table and the statue. Now, if I want to deselect an item, all I have to do is hold down Control and click on any items to deselect them. Now, all we have is the statue and the left chair selected. And here's another tip. If I have the chair selected, hold down Alt and the left mouse button to drag out a new chair. Let's say if I want to drag this chair all the way over there, then I'm going to have to drag it across the screen, move my camera, drag it across my screen again, and it's just a huge hassle. Another way I can do it is by holding down the Shift while I'm dragging. So if I'm going to hold down the left mouse button on one of these arrows and I want to lock my camera to the object, simply hold down Shift and you're able to lock a camera to an object, which can save on a lot of time. So I'm going to press delete and let's create a very, very simple scene just to get a hang of all the controls. So to begin, I want to hold down Shift and let's select these two chairs. Hold down Alt and duplicate them out. So let go, hold down Alt and left mouse button again, Alt and left mouse button again. Now let's go rotate some of these chairs. That's how they're facing inwards. So select a chair, press E to get the rotation gizmo up and have them all face inside. just like this. Again, it doesn't have to be pretty perfect because we're just trying to get used to the controls at this point. And then I'm going to select the table, press R to scale it. And I want to elongate the table just a little bit, maybe even in its x-axis. Press E again. Let's rotate this. Press W, move it into the middle right there. Select the chair, hold down Shift. Let's select the other chair and move them all in. Let's select the statue, move it into the middle. Press R, scale this up, and maybe add some lamps on both sides of the table. So press Control and Space. Within our content, starter content, and props, we have this SM_lamp ceiling. If I drag it in, this is exactly what I want, but right now it's in the opposite direction. So I want this to be placed on the ground. I can press E, rotate this, and try to get to 180 degrees. Or I can press Control Z and re-enable snapping for rotation right here. And rotate it exactly -180 degrees, which is what I want. So press W and let's move it. That's how it's directly placed against the ground, like right here. So I could try to guess exactly where it is, or I could snap any object I have selected to the object that's directly below it by pressing the end key. So that's END, not the end letter. So press END, end, and snap it there just like that. So press R again, scale this up in the Z axis, hold down Alt, and drag it in both the Y and X axis right there like this. Let's hold down Shift again and drag both of those across our world just like that. And I would say congratulations, you now have a very, very simple level. This is definitely not the best map, but it is pretty good as a first level. Now that you've finished your first level, it's time to move on to the post-process volume. So we're going to go over how we can change the settings of our viewport camera, specifically exposure. While in the process of creating our first level, you might have noticed that if we zoom into the shadows, we see our screen gets brighter and brighter and brighter. And then when we zoom out, our screen gets darker. So that is auto exposure. And what exposure is trying to do is it's trying to mimic the way our eyes work. So for example, if you've ever been in a very dark room and you decide to jump out into the daylight, you can feel your eyes start to hurt and everything is really bright, but slowly over time your eyes start to adjust until everything comes into focus. And that is exactly what Unreal Engine is trying to mimic by brightening our screen and darkening our screen. So I think we can create a better example by duplicating this map and creating a little house. So to do so, let's press Control and Space to go into our content drawer. And I want to duplicate minimal_default, which is right now located in starter content and maps. So right here is the current level that we have. There's a little asterisk right next to it, and that tells us that it needs to be saved. So press Control S to save the level, and to duplicate the level, simply press Control and D to duplicate. Now let's go rename this to post process example, and let's go save it. So if I double click on minimal_default, this is the current map that we've been on. And then if I double click on post process example, this is the new map that we're about to edit. Now notice that our grid is pretty large right now. That's because we have our snapping set to 100. We can make the grid squares smaller by setting this back to 10 as its default. So now our grid is a little bit smaller, or you can press G to hide all those editor widgets. Now I want to start deleting all these objects. So simply select an object and delete it to get rid of it. And here is a little tip. If I go into the outliner, since I do want to delete all these chairs, I could hold down Control and select each chair individually, or I can select the first chair at the very top of the list, hold down Shift, and select the last one, and then it'll select everything in between. So Control is to select individual objects, and hold down Shift is to select a row of objects. And press Delete. Now let's create a little hut. So I'm going to come up to Add, and hold down the left mouse button on Cube to add in a very simple cube. Keep in mind that this is just for demonstrations to show exposure, so this won't be the best. Hold down Alt, let's go duplicate this wall, and hold down Alt again. Press E, and I want to make sure snapping is turned on so I can rotate this exactly 90 degrees right there. Hold down Alt again, and drag it out just like this. So hold down Alt, rotate this as a roof. And I do want a slight opening so that the sun can come through and illuminate the inside of this hut. Right here, like that. So now, notice that if I zoom in on this and go inside the hut, we can see our screen get brighter and brighter and brighter. And then as soon as I fly out, our screen gets darker. So when I go inside, our eyes adjust, it gets lighter so that we can see exactly what is inside the hut. And then if I zoom outside, our eyes get darker. Now, this can be annoying if you are building out worlds. So to turn it off and to lock your screen to a certain brightness, we could come up to lit and all the way down here under exposure, uncheck game settings. Now we have a constant brightness that even if I go inside the hut, we see that our screen isn't getting darker. Now, right underneath game settings, we have EV100. If I bring this down, our screen gets brighter. And if I bring this up, our screen gets darker. So we can leave it at 0 for now. Now, there is just one issue, and that is this change doesn't apply to gameplay. To play the game, come up to the toolbar and click on the play icon. Now we are currently in game. But if we, let's say, go into the hut, we see auto exposure is turned on since our screen gets brighter, and when I leave, the screen gets darker. On a side note, if you want to stop playing the game, press the escape key to exit out. Maybe this is what you want. When you're building out your world, you have a constant exposure, and then when you're in game, you have auto exposure turned on. But if you do want to edit the exposure directly in game, this is where post-process volumes come in handy. Now, we won't be able to see the exposure changes with the post-process volume, with game settings turned off, so come up to lit and make sure game settings is turned on again. And within the outliner, by default, we will have a global post-process volume for this map. So with the post-process volume selected within the outliner, we see that we have a drop-down called exposure, and we have exposure compensation. Now, in order to edit any of these properties, you want to make sure that they are turned on first, and then we're able to adjust exposure, but auto exposure is still turned on right now. So what we can do is select metering mode, and instead of auto exposure histogram, select manual. Now we control exactly what our exposure is with the exposure compensation. So if we leave it at 9, press play again, we see that we don't have any auto exposure in game. So you might be wondering exactly what the post-process volume is. Well, the post-process volume is a great way to add some effects after everything has been rendered. So the post-process volume only affects our camera. For example, maybe we want some more bloom. So we can select bloom, and right now the intensity is at 0.675. I can boost this up all the way to, let's say, 8. And maybe if I want the default values back, instead of trying to guess what the default values are, I could come over here and select that backwards arrow, which will set everything back to its default value. We also have a bunch of other settings. For example, under image effects, we can add a very strong vignette. So right now it's at 0.4. We can bring this up all the way to 1. So there's a lot of darkening around the sides of the camera. Or we can completely turn off vignettes by bringing it down to 0. So by default, Unreal does have a little bit of vignettes with it being at 0.4. We can also go down here and change some of the color grading. So maybe if I select saturation, I can move the wheel around. And we see just a little bit of changes. I can even boost the saturation down here. So instead of 1, drag this up. And now we have a really vibrant and saturated scene. And of course, I can uncheck this to get rid of that change. So if you want, there are a ton of different settings. You can go through and see what all of them are. But you might be wondering, how do I create a post-process volume if I don't have it inside of our world? So to begin, I'm going to press G key to bring back all of our editor widgets, select the post-process volume, and let's delete it so we can go over how to create a post-process volume from scratch. Of course, we're going to select the add button. It's going to be under volumes. Down here, we have post-process volume. So simply drag this into our world and we see that we have a little square. So let's make a very quick change. So the change I want to make is down here within globals and saturation. Instead of 1, I'm going to change this to 0. But we notice that there are no changes to our camera right now. That's because the post-process volume by default only affects whatever is inside the post-process volume. So if we move into the cube, we can see those changes taking into effect. And right now, by changing global saturation, bringing it down all the way to 0, it gives us a black and white world. Now, what if I want this post-process volume to affect our entire world? Well, scroll all the way down here, and under Infinite Extent Unbound, make sure that's turned on. So that's how we don't have to be within the post-process volume for that post-process volume to take effect. Now it's time to go over materials, but do keep in mind that materials can be a little bit complicated, especially if you're brand new to 3D art. So if you do find yourself a little bit lost throughout this course, do keep in mind that you can always go back in a section and rewatch it. To demonstrate materials, I want to create a brand new map. So to do so, let's create a folder where we're going to store all the assets we create. So I want this folder to be under content, right next to the starter content folder. Right click and select a new folder. I'm going to call this folder My Stuff and double click to go inside of it. Now to create a level, I could right click and under Create Basic Assets, select Level, but I want to use a level template since this will just create a completely blank level. So to use level templates, you want to come up to File, New Level, and you can select Open World or Basic. I'm going to select Basic. And now we have a pretty basic level. It's just the floor right here and the sky. Now, in order to save this level in a specific location in our content browser, you need to press Ctrl and S. And it's going to ask us where we want to save this level. Select My Stuff. And let's call this one Material Example Level. And then select Save. Now, pressing Ctrl and Space to bring up my content drawer, we can see that under My Stuff, our level is saved. So if we ever want to go back into this level, I just have to double click and we will open up that level. Now, I do want to make some adjustments. If we zoom in on the floor, we can see that our grid is showing through and it's right on top of the floor. Now, this grid will be distracting when we're showing off materials. So I'm going to come up to Show and uncheck the grid to hide it. That's how all we see is the floor material. Also, I think this floor is a little bit too big for our purposes. So I could use R and hover in between the Y and X axis to then scale it down like this. Or alternatively, within the details panel of this floor, I can set it to 1 in the x-axis, 1 in the y-axis, and 1 in the z-axis, just to give us a smaller floor. I also want to add in an object to place our materials on top of, and we can do so by pressing Ctrl and Space. And Unreal actually comes with a bunch of assets and objects by default. So this is content that is not located in starter content. Instead, it's located in the engine folder. And if you don't see your engine folder right here, that's because you need to come to Settings and make sure Show Engine Content is enabled. Now we get access to all of Unreal's default content that is contained in every single project. So let's go into Content, and I believe it is under Engine Meshes, and it's specifically SM_Matte Preview Mesh. Now we can also select Engine and type in SM_Matte to bring up that asset. So I'm going to drag it into our world. And let's rotate it 90 degrees. And we can rotate it 90 degrees exactly by making sure snapping is enabled up here. Now I also want to control the exposure, since if we zoom in on the shadows and zoom out, we can see that auto exposure is enabled right now. So let's create a post-process volume by going to Volumes, Post-Process, simply dragging it out. I want this to affect the entire world, not just whatever is inside this box. So scroll down and make sure Infinite Extend Bound is turned on. Now, if we go up here under Exposure, make sure Metering Mode is set to Manual instead of Auto, and Exposure Compensation, we can bring this up. I found a value of 11 to be pretty good. Now, as a reminder, if your exposure isn't changing from your post-process volume, you need to make sure that in Lit, Game Setting is turned on, because otherwise it's going to default to EV100 setting right here as the exposure amount. So make sure Game View is turned on. That's how we're using post-process volume. And since I do like my scene right now, you want to make sure to save everything with Control and S. And actually, I think I'm going to bring down my exposure to Let's leave it at 10.5. So now it's finally time to go over materials. And adding a material to your world is actually pretty simple. So press Control Space, and luckily starter content comes with a bunch of materials by default under the materials folder. So let's double click into materials, and we see we have a bunch of materials that we can use. So to add a material to our world, you want to simply hold down the left mouse button and drag it until you're hovering over whatever object you want this material to be placed on, and let go. It is that simple. So now we have a brick floor, or for example, to make this object steel, I can drag a steel material onto the object and let go. We can even add grass right there like this. And we can see the reflections updates on the metal right there whenever we are switching our different materials, which is pretty cool. So let's select the grass. And I do actually want to make this just a little bit bigger. So let's scale it in X and Y axis like this. And I think the screen is too bright, so I'm going to bring its exposure compensation down to 10.25. So that's the basics of adding a material to our world. What if we want to create or edit a material? Well, to create a material is also pretty simple. It's just like creating a level. Press Control and Space and come into My Stuff where we're going to create our material. Right click, and under Create Basic Asset, select Material, and let's call this First Material. And press Enter and double click on it to open up the material editor. First off, before we go over any of these settings, you'll notice that my window is right now floating. So something I like to do with all my editor windows is to hold down the left mouse button on the tab and then dock it up here just like this. That's how really quickly I could switch in between my main level view and any of my editor views. So in the middle, we have the material graph. Essentially what the material graph does is basically we have a bunch of nodes that connect to each other, and their end goal is to eventually be outputted into one of these outputs right here, which will create the actual material. Now the controls are pretty similar to the controls of our viewport when in orthographic view mode. So hold down the right mouse button to pan, and then use the scroll wheel to zoom in and out. So right mouse button pan, scroll wheel zoom in and out. You can select nodes by just clicking on them or holding down the left mouse button to marquee select. Now to the left right here is the viewport. If you hold down the left mouse button, you can pan around this preview mesh right here, which helps us see our material when we're editing it. Now we can change the preview mesh down here. So maybe you want to use a cylinder or a flat plane, a square, but for now I'm just going to keep it at a sphere. And right below that is the details panel. So if we select a node, we're able to edit that node's properties right here in the details panel. So how do we create a node? Well, we come all the way over here to the palette, click on it, and now we have a selection of all the different nodes we can use to create a material. We can also right click anywhere to get that same palette. So under palette, I want a constant 3 vector under constant. The reason why is because a constant 3 vector is essentially Unreal's version of color. It's R, G, and B for red, green, and blue. Right now this node is set to black. I could edit it by coming to the details panel and double clicking on the color to get a color picker, or I could double click on the node itself to get that color wheel. So notice how when I do change the color right here, there are no changes. That's because its value is set to 0. I can bring up its value by clicking on this rectangle right here. So now when I change this color, we notice that color changing. And when I do like a color, I want to confirm that this node is going to stay that color by clicking OK. So now we have our first node with a new color. Essentially, if I hover over this pin right here and hold down the left mouse button, I'm able to drag out a wire. And I can choose where I want to place these wires in any of the inputs right here. Now, of course, because this is a color, it should probably go into base color. So with my left mouse button still held down, I'm going to hover over the base color pin and let go to connect it. Now we can see that our color is affecting our material. So let's see what this looks like in our level. So press Control and Space, and let's drag first material onto the sphere, and notice that there are no changes right now. This looks like the default material. And that's because we first need to compile our material after we make any changes to see that change in our level. So go to first material, and to compile a material, you want to click on the apply button. And also while we're at it, let's save it. So if Unreal crashes, we don't lose our progress. Now, if we come back to our level, we can see that change took effect. Now jumping back into first material, If we, let's say, change the color to a light blue, jump back into our level, we see that there were no changes because we need to make sure after we edit a material that we compile it with the apply button. And now we see that light blue. That's how you add color. Now, what if you want to edit how shiny or reflective the material is? Well, on our first material, instead of editing the base color, we're now going to edit the roughness channel right here. And roughness doesn't take a color value, of course. Instead, it takes a scalar value in between 0 and 1. So 0 means it's really smooth, and 1 means it's really rough. To get a scalar value, you want to come up to Palette, and under Constant, select the Constant 1 value. Left mouse button hold, and drag it out. And now we get a node that is simply a number. So 0 will be smooth, 1 will be rough. Let's make this really smooth by giving it a value of 0.1. And simply left mouse button hold and drag it into roughness. If for some reason you ever want to break a wire, all you have to do is hold down Alt and hover over any of these pins and left click. So Alt and left click to break any pins. And we will not see this change in our level unless we press apply. So jumping back into materials, I'm going to press F and hold down Alt and left mouse button to then pivot around my material, all its nice reflective values. Notice how we can see all the different clouds in the sky being reflected off the material now. So that's roughness, but what if we want to make our material metallic? Well, go back into first material, and this is where the metallic input comes in really handy. So we need another constant vector, and we could get it by selecting that node and pressing Ctrl and D to duplicate it, or I can get it from the palette, and of course I can right click and simply type in constant. So normally when I am getting nodes in, I just right click and type in the name of the node and press enter to bring it in. So I'm going to give this a value right now of 1. Since by default there is no metallic value, it's set to 0. So setting it to 1 and plugging it into metallic will make this blue pretty metallic. And in fact, let's go change the color to something orangey, press apply. And now we made a gold material. It's very important to point out that Unreal Engine's material system is based off of physically based rendering, or PBR for short. For example, right now I have a project open up to demonstrate PBR values, and the two main ones to know about are metallic and roughness. We've already played with them, and essentially both of them are on a scale from 0 to 1. Now by default, metallic is set to 0, so there is no metallicness on the material, and our roughness is set to 0.5. Now as I bring down the roughness, we see our material get shinier and shinier. And then if I bring it up, our material gets rougher and rougher. So if I bring it all the way down to 0 and play with the metallic value, which is right now as default value of 0, so it's not metallic, but slowly we can see it goes from a plastic material all the way to a very shiny gold material. And if we play with a roughness value, we can really see those changes taking effect. Now, both these values are clamped from 0 to 1. So let's say if we input a roughness value of -1, then it'll be clamped to 0. Or if we go above 1, then it's going to clamp it down to just 1. So keep that in mind that if you do try to input a value that's outside the 0 to 1 range, you won't see any changes. And it's important to point out that generally for metallic values, we never go in between 0 and 1. You won't really see a material that's 0.5 metallic. Instead, materials are either all the way 0 or all the way 1. Here I am back in our original project, and you notice that we no longer have our material opened up here. Well, that's fine. You can always open up the material on any object by clicking on that object, and then in the details panel, we see all the materials that are currently on top of that object. So just double click to open up our original material we created. Alternatively, you'll see a little magnifying icon right there. If I select that, then it's automatically going to jump to that material's location in our content drawer. And we can double click to open it up right there like that. So the PBR sliders we were just playing with are the metallic and roughness values right here. So those sliders correspond with these values. So hopefully you understand exactly what they do now. Now I'm going to make a slight edit. So for metallic, let's bring it from 1 to its default value of 0. So that's how it's kind of like a plastic material right now. And also, I think it's a little bit too bright. So double clicking on the color, I'm able to decrease the brightness by playing with its value. So bring it down a little bit, press OK, press apply. And now I do think we have a nice material, but normally when you have plastic outside, it wouldn't be this uniformly shiny. you would expect dirt to pile on this material and make some areas of the material rougher than others. So let's jump into first material, and to add a texture, press Ctrl and space. Let's go into starter content. Since starter content comes with a bunch of textures under the textures folder, and the texture I want to use is specifically T_Perlin noise. So to get a texture into your material, simply left mouse button and hold, drag it in, and let go like that. Alternatively, you can right click, type in texture sample, select that, and then within the details panel, in the drop down of texture, go ahead and find whatever texture you want to use and select it. So that's alternative way to add in a texture. And now that we have T_Perlin noise, if we open it up, we can see that it's just black and white. All the pixels of the texture represent a value in between 0 and 1. So they are perfect to plug into either metallic or roughness. Plug our texture into roughness since I wanted to drive the roughness value of our material, and delete the old node since I no longer need it. Press apply, jump back into our material example. And now if I angle it with the sun, and here's a nice tip, if I hold down Control and L at the same time, I'm able to rotate that sun. So I'm able to bring it down, like move it around, and see what our material looks like in different lighting scenarios. And right now our material is looking a lot more realistic. We can see that because of our material, all the black spots represent shiny areas and all the white spots represent rough areas, which gives our material a nice smudgy look to it to just break up that uniform shininess. At this point, let's switch up the colors. Since if I go into color mode by going Alt-3 for unlit, we can see that's still all one uniform color. Pressing Alt-4 to go back into lit mode, I want it where all the smudges are a different color that's a little bit more brown than orange to represent dirt. So let's go back into first material, and we can duplicate this by pressing Ctrl and D, or we can right click and type in constant 3 vector and select that. So double click on this. I'm going to give it a brownish color, maybe like right here, press OK. And now I want to lerp in between the orange color and the brown color, depending on our alpha texture. So wherever there's white, I want it to pick brown, and whenever there's black, I want it to pick orange. And we can do this through a linear interpolate node. So right click, type in linear, and then interpolate, select that. Or a shortcut is to hold down the L key and left click. So L left click brings in the lerp node, since we are going to be using that node a lot. And on the subject of hotkeys, if I hold down 3 and left click, that gives us a constant 3 vector for color. Or if I hold down 1 and left click, that gives us a basic scalar value, like for metallic and roughness. So 1 and left click for scalar value, 3 and left click for color. So let's plug this up to A, plug the brown one to B, and for alpha texture, I want it to lerp depending on our original mask that's right now driving our roughness. So drag RGB into alpha and drag that all into base color. And now we can see that where our object isn't shiny, the color changes to a dirty brown. Pressing apply, jumping back in here, we notice that our material is definitely a lot more realistic. You can imagine that this was once plastic or really shiny paint, and over time dirt has slowly started to build up on the material, making it pretty dirty. Now we can make this even better by, instead of lerping in between two colors, we're lerping in between a color and another texture. So there's a very good texture under starter content textures, and it is right here. So it's T_metal rust. Open this up, we can see what it is, but right now we don't notice anything. That's because the alpha channel is turned on, and the alpha channel handles opacity. So if you ever open up a texture and you don't see anything, make sure you come up to A and uncheck that. So now we can see it. And while this is rust, I do think it functions well as dirt, especially for a very small detail. Like on this material, it's going to be hard to tell that this is rust instead of dirt. So let's drag this onto our material graph and plug it up right there instead of the original dirt, and press apply. So congratulations, you just made your first material in Unreal Engine 5. While it's not the best, it definitely is a good introduction to the power of the material graph. Before we continue, we first have to download some free assets I created for this tutorial to help us learn Unreal Engine. You can find a link to download the free assets in the description of this video. The reason why is because in this section, we're going to go over how we can take a texture and import that texture into Unreal Engine and use it in one of our materials. So to begin, I've already downloaded the assets for this tutorial. Right here, intro to Unreal 5.zip. Double click to go inside of it and double click to go into intro Unreal 5. So I want to make sure that I do unzip some of these assets, specifically the beginner assets folder. To unzip it, simply drag it onto our desktop. We are going to go over castle assets and intro Unreal project in just a bit, but for now we don't need these. So I'm going to exit out my zip folder, and now we have a brand new folder with a bunch of assets we're going to import into Unreal Engine 5. So to begin, we're going to create a very simple material using these three textures right here. You could probably guess that Spanish pavement color handles the color of the texture, Spanish pavement roughness handles how rough the texture is, and the normal map, which is this purple texture. While it does look pretty weird, don't worry, we are going to go over what a normal map is in just a second. But for now, let's go import all three of these into Unreal Engine 5. So let's open up Content Drawer and go into My Stuff, because you remember we created a folder called My Stuff to hold all our assets. And I'm going to hold down my left mouse button and drag all these assets into my Content Drawer. So you want to make sure that your Content Drawer is open so you are able to drag it in, let go, and automatically these three textures have imported. So we'll notice that all three of these textures have little asterisks right there that tells us that these textures need to be saved. So select all of them and press Ctrl S, or we could have clicked on Save All. So if I double click on Spanish base color, we can see that the texture has successfully been imported into Unreal Engine 5 and sRGB is turned on. For color textures, we want to make sure sRGB is turned on. For everything else, such as masks and normal maps, we want sRGB turned off. For Spanish pavement roughness, we see that's turned on. I'm going to check this to false and save it. Now for our normal map, if I double click on the normal map, Unreal is smart enough to know that this is a normal map, so it already automatically sets some of the parameters. sRGB is turned off, which is what we want, and compression setting is set to normal map. Now, if you do import a normal map and Unreal doesn't know it's a normal map, then you want to make sure that you set compression settings to normal map and sRGB turned off. So let's go create our material by right clicking, go to materials, call this one M underscore Spanish pavement. Now you do not have to add the M underscore in front of our name, but just for convention, I like to add M underscore over all of my materials to tell me just by quickly reading the name of the asset that this is a material. So double click to go into M underscore Spanish pavement, and let's dock it up here so we can switch in between our level and our material graph. Now I'm going to press Control and space, and I could drag in each texture individually, or I can hold down Shift and select all of them and drag in all of them at once. So I'm going to leave my normal map off to the side since we are going to go over this in a bit, but let's just handle our roughness and our base color. So base color will go into, of course, base color, and roughness will go into roughness. Now we don't have to play with the metallic value because metallic by default is set to 0. Because our material is a metallic, we can leave the metallic input empty since it will just default to 0. And within material example level, let's apply this brand new material to our floor. Right away, I notice that there are two issues with the material. Number one, our material is tiling way too much. It's too small. And number two, there is no depth. There is no shadows given by the crevices of our Spanish pavement. It's almost as if someone got wallpaper and plastered it onto the floor trying to pretend like it's real flooring. So to fix this, we use normal maps. So essentially what normal maps do is that they fake bumps. So they fake depth and they make it look like our texture actually has height when in reality it doesn't. It's just a material. So to add a normal map, it's pretty simple. As you can probably guess, we grab the normal map and simply drag it into normal. So let's press apply and immediately we'll see that our texture looks a lot better. There's actual depth, and if we come to the shadow right here and add in a basic light, we can see that as I move this light around, the material itself is casting shadow. So since the light is right here, now the crevices have a little bit of a shadow. So normal maps really go a long way to make our material look really realistic. Now let's fix our tiling, because in my opinion, I think it's tiling way too much right now. And to fix tiling, let's go into M underscore Spanish pavement, and we're going to use a brand new node. So right click type in texture coordinates. So let's grab that. Essentially, texture coordinates will allow us to change the scale of our textures. So if we just drag it into UVs, nothing will happen. That's because we need to hold down M and left click to add in a multiply node. Or we can right click and type in multiply, since we are going to be multiplying the value that comes out of texture coordinates. And on a side note, if you ever want to break wires, hold down Alt and left mouse button to break it. So let's move multiply up here like this. Hold down the left mouse button and drag it into A, and then drag this out into the UVs, just like this. We can multiply this by a number, which is a constant scalar. So as you can guess, we're going to type in constant and grab one constant. So plug this into B, and let's give this a value of, instead of 1, something smaller, like 0.5. And this will increase the size of our texture to make our Spanish payment bigger. And we can see immediately that it did make the texture bigger. We can maybe even make this a little bit bigger. Let's try 0.35 and press apply. And now I do like the scale of our payment. We can also add in a little bit of customization. So maybe I don't like the tint of this. I want to make our payment a little bit more red or a little bit more green. Well, I can marquee select by holding down the left mouse button anywhere in my graph, select all my nodes, move it back a bit, since we're going to be adding some nodes right here. So I'm going to hold down M and left click again to add in the multiply node and drag RGB into it like this, and then drag it out into base color. I actually want this RGB to go into B, not A. So I could hold down Control and hold down my left mouse button to then grab this wire and place it into B to just switch it from A to B. Now I'm going to hold down 3 and left click to add in a constant 3 vector. And I'm going to set its default value to white and plug this into A. So since R, G, and B are all 111, there's going to be no changes right now with the Spanish payment. But if I want to make our Spanish payment a little bit more red, instead of it being white, I'm going to move it into the red direction and press apply. We can already see a change right there. And now our Spanish payment is really red. So generally you don't want the tint to be that intense. So just a little bit red, kind of like an off-white, and then press apply. Now we do have a more reddish payment, or we can even add some greenish blue, and we subtracted a lot of red from our Spanish payment, and maybe you do like the look of this better. Right now our material looks nice, but there is one big issue, and that is it is not real time. So whenever we make a slight adjustment, we have to press apply and wait for it to compile in order to see changes in our world. And as you can imagine, if we have a really complex material and we make a slight change, the compile time can take a while. So we're able to get around this with parameters. So parameters allow us to make real-time adjustments without any compile time whatsoever. So let's jump into it to show how to use them. Before we create a parameter, we first need to create a material instance. And this material instance will hold all of our parameters. So to create a material instance is pretty easy. First, you want to find the material you want to create an instance of. In our case, it's a Spanish payment. We already have the location open up within our content drawer, but just as a reminder, if you want to find exactly where this material is, select the object with the material on it, and within the details panel, select the little magnifying glass to jump to that location in your content drawer. So here we have m_Spanish payment, and to create a material instance, simply right click on your material and go create material instance. Now, instead of calling it m_Spanish payment, I'm going to call it mi_Spanish payment. So I like to use an M to tell me that this asset is a material, and I like to use mi to tell me that this asset is a material instance. So let's double click to go into the material instance, and we'll see that we don't have any parameters right now. A parameter is essentially a setting that allows us to change our material. And that's because I need to tell Unreal exactly what settings within our material I want to make a parameter, what variables I want exposed to the material instance. So for example, if I want to make this value right here a parameter, right click and go to convert to parameter. It's that easy. Now it's going to ask for a name. Let's call this one size. And now within our material instance, we notice that there was no change because I have to press apply. And now we get a brand new parameter within our material instance called size. Now, before we can play with this, let's go add our material instance to our world. Since this Spanish payment is not our material instance, instead it's m_Spanish payment. So let's go grab our material instance and drag it on there to make it the instance and not the main material. Now, with our material instance opened, I'm going to check size, and let's go play with this value. So I can see that as I increase it, it's all updating in real time. And as I decrease it, I'm able to see exactly the size that I want. So trying to pick a size this way, instead of having to jump into our material, manually edit something, and then click apply and jump back, by just exposing it as a parameter for our material instance, it makes creating materials a lot easier and, in my opinion, a lot more fun. Now, we're not just limited to creating parameters for scalar values. We can even go into m_Spanish payment, and let's turn this color into a parameter. So call this one color tint, and let's go back into material example. And we do not have anything because I forgot to press apply. And this color tint is available to us. So maybe I don't want it to be this kind of greenish. I just want to bring it over to, let's make it even more green like this. I can even bring down the value to make it pretty much no color, just pure black. So we can even give ourselves more control. For example, right now our normal map is doing a pretty good job, but what if we want to decrease the effect of the normal map? Or we want to make this normal map even more intense so that the shadows are more pronounced. Well, if we jump into m_Spanish payment, we can control the intensity of a normal map with the flatten normal node. So let's go hook up the normal map to normal right there, and the result to normal. Now it's asking for a flatness value. If I hover my mouse over it, it says the default value is 0. So I'm going to hold down 1 and left click to create a constant scalar value and hook it up right there. Now I'm going to right click and go convert to parameter. And let's call this one normal flatness, just like that. So 0 won't do anything. Press apply, jump back into our world, and check normal flatness. 0 is its default, there are no changes. But if I increase normal flatness, our normal strength decreases because it's getting more and more flat. But if I make this value go below 0, so into the negative ranges, like -1, then we have some really intense normal maps. Maybe even, let's go -5. Now this is almost like it's from a war zone. We can even add some more adjustments. So let's jump back into m_Spanish payment. And I want to control the intensity of this normal map with just a simple multiply node. So I could select this multiply, press Ctrl and D to duplicate it, or I could hold down M and left click to bring in a multiply node and hook it up like this. Now I want to bring in a parameter scalar value for B, so I could hold down 1 and left click, then right click to convert to parameter, or a shortcut is to hold down the S key and left click to create a constant parameter. And it's going to automatically ask us for a name, call this one roughness, strength, and plug it up like this. And this will immediately get rid of any roughness, make it pure glossy. We don't want that. So let's go increase the strength from 0 to 1, which won't do anything by default. But this gives us the ability within our material instance to then, let's say, increase this roughness strength to make our pavement even more rough. So maybe beforehand it was at 1. You think that this is a little bit too shiny. Well, you could just increase it and get the exact roughness amount you want. So with just a couple of controls within our parameter value, we're able to, in real time, completely change the way our material looks, which is pretty amazing. Now, I prefer the way this material looked like originally, so I can reset all the values to its default value by clicking on the arrow icon. So set that to 0, 1, 0.35, and set it back to a little bit off green. Now that we know how to create material instances, it's now time to go over master materials. Essentially, a master material is one material to rule them all. So imagine we have a single material, and from this material, a bunch of material instances are created that are very different from each other. These instances can be anything from paint, concrete, wood, pretty much anything you can imagine, and they all share the exact same master material. So I know what I just said sounded a little bit complicated, but it's best to show with an example. We've already done a lot of the work creating a master material, and it's actually m_Spanish payment. So we're going to turn this into a generic material from which we can create multiple materials from. So let's jump back into our map, and within the content drawer, instead of calling this M underscore Spanish payment, let's right click and go rename and call this one M underscore master material. Just like that. So let's double click on it. And I want to make this master material pretty generic. So I want all my parameters to have the default values where if I didn't edit any of them, it would basically be the same as if we plugged in all 3 of these textures without any of those edits. So down here, normal flatness won't make any edits or changes to the normal map, which is what we want. Normal strength is right now set to 1, which will not change the roughness map or make it more rough or more shiny. Also, I noticed I misspelled strength, so let's go fix that. And up here, color tint isn't pure white. If it was pure white, then it wouldn't edit the base color, but it's an off green right now. So I want to make this pure white. Let's double click on this, and I can do so by grabbing the saturation and bringing it all the way down like that. So now we have 1, 1, 1, and make sure your value right here is all the way up to the top like that. Now we have pure white, which isn't making any edits to the base color. Now we are making an edit to the multiply node right here. So this is a size of 0.35. So it's going to decrease the tiling and make our texture a lot bigger than what it would be by default. So I would need to set this to its default of 1 right there. So let's press apply. And as a reminder, if I open up mi underscore Spanish payment, essentially by changing the values within the master material in a material instance, we see size right here is 0.35. To change it to its default, all you have to do is click on the arrow like that. So for color tint, it's right now green, which is what it was originally. If I click on the arrow, now it's pure white. So let's go back. And I also want to expose the textures right here. So I want to be able to swap out each of these textures on the material instance. To do so, you can probably guess, of course, we're going to right click and go to convert to parameter. Call this one color, right click right here, roughness, and right click, convert to parameter, normal. So let's press apply. And now we get access to all those textures right here. So if I just turn and activate all of these, I can switch out any of these textures for something else. For example, I can switch it out with grass. And now we have grass as our base color, but our roughness is still using the Spanish payment and the normal map. So I'm going to press Ctrl and Z to get rid of that. But you can imagine that if we did have a normal map for grass and a roughness for grass, that I could just swap it out really quickly. And instead of it being a Spanish payment, it is now grass. But our master material isn't complete yet. It is missing one function, and that is allowing for metallic maps. Since our Spanish payment right now isn't metallic, but what if we did have a metallic material and we want to use our master material? Unfortunately, there is no place that we can put a metallic map. So let's jump into M underscore master material and let's add that right here. So we're just going to duplicate the roughness map. So press Ctrl C, Ctrl V, because just like the roughness map, the metallic map is a mask that shows where in the texture the material should be metallic. And instead of calling it roughness, call this one metallic. Drag it up right here. That's why I was using the same UVs. And simply plug this into metallic. Now we do have the issue, and that is now even a material like our Spanish payment, which is a metallic, will have metallic values by default, which is something we don't want. So we want the ability to be able to turn on and off this metallic map right here. So let's jump into M underscore master material, and we could give ourselves a toggle for this with the static switch parameter and select it right there. So let's call this one is metallic. And then if it is, then we're going to use the metallic map. But if it's not, we're going to use the default value of metallic, which is just 0. So hold down 1 and left click to bring in a constant scalar value. And by default, it is 0. So plug it up like this. And now we have a nice switch where, let's say, for example, if we do have a metallic material, all we have to do in the material instance is check is metallic to true and drag in that metallic map right here. But if I turn it off, then it gets rid of that metallic map. So let me go make some adjustments to our Spanish payment, bring down the size. Also, it's a little bit too reflective right now. So I'm going to increase the roughness strength just a little bit to make it a little bit less shiny. And now we have a pretty versatile master material that we can use for a whole range of different scenarios. And we're going to use this master material in the next chapter. Now that we can import textures and have a master material, let's go over how we can import 3D objects and bring them into Unreal Engine. And it's very important to know that in Unreal Engine, 3D objects are called static meshes. And static meshes, by itself, are just a collection of vertices and faces in space. If you want to change the way that object looks, then we need to add on a material, and generally this material is comprised of multiple textures. So to break down how a 3D asset is constructed in Unreal Engine, first we have our static mesh, which is a plain 3D object. And then to change the way that static mesh looks, we need to add a material. And this material can be comprised of multiple textures. So to better get a sense of how 3D assets are made, let's create our own 3D asset in Unreal Engine. The 3D object we're going to be importing into Unreal Engine right now is included within the beginner assets. So double click to open this up, and it's the woodcrate.fbx. So we're going to import this into Unreal Engine. If I double click on it to see what this 3D model is, we can see that it's just a very simple crate. So nothing too fancy, but it will get the point across on how we create 3D assets in Unreal Engine. So let's go into content drawer, and under my stuff, I'm going to save everything, right click, let's create a brand new folder, call this one wooden crate. Let's double click to go inside of it. So wooden crate will have all our assets that combine to create the wooden crate asset. So first, let's import the 3D model. So hold down left mouse button, drag it, and simply let go. Now we have a bunch of FBX import options. Generally, I keep it at default. If you do see something is different, click on reset the default to get those default values back. Now, generally, under materials, for create new materials, I do not create a material. Since we are not going to be starting from scratch, we're going to be using the master material on this. And for import textures, uncheck that to false, since we aren't going to be importing any textures, since I'd rather import those textures manually, and click on import. So we might get this warning, that's fine, you can ignore that. And now if I double click on the wood crate, we can see that our wooden crate has been successfully imported into Unreal Engine 5. I can drag this out into my scene, scale it, rotate it, move it around. Pretty much it has all the same functionalities as any of the objects that Unreal Engine comes with. So that's how you import a 3D object. Let's go over how we can create a material for this 3D object. Now, luckily for us, we've already done most of the work, and that is our master material. So m_master material has everything that we need to create a material for this object, except the textures. So let's import the textures real quickly. Press Ctrl and space to bring up the content drawer. Select all of them with Shift and drag them into the content drawer. So let's double check that all our maps are correct, starting with the base color, and sRGB is turned on, which is exactly what we want. Would crate_metallic should have sRGB turned off since this is a mask. And this fancy texture right here we are going to ignore, but I will go over it in just a bit. And right there is woodcrate_normal. Let's double click, make sure that it was imported as a normal map. sRGB is turned off, and compression settings is set to normal map, which is exactly what we want. And for roughness, of course, since this is a roughness mask, make sure sRGB is turned off. So let's go save everything and create a material instance of our master material. So let's right click, create material instance, and call this one mi_wooden crate. So drag this into our wooden crate folder and move here. So double click, and we have our material instance. So I'm going to apply this to our crate, and obviously it's using the wrong textures. So let's open up our material instance for wooden crate and activate color, normal, and roughness. So let's drag those textures that we want, specifically color into base color, roughness into roughness, and normal into normal. Our material is almost complete, but we are missing one last thing, and that is the metallic map to make our nails metallic. So to do so, this is why we added the is metallic switch right here. And now we get the metallic texture. Let's turn this on, find where our metallic map is, and simply drag it onto texture and let go like that. And now our nails are metallic. We can see it successfully reflecting the sun. So that's pretty amazing how very quickly we were able to automate the process of creating a material by using our master material. So we could create a material without ever even touching the material graph by just creating an instance of that master material. And what's amazing is that we still have access to all the parameters right here. So I can change the normal flatness to -5 to increase the normals, or I can go into roughness strength and decrease the roughness value to make our box even shinier. I can even go into color tint and give it a slightly orangey reddish tint. Now, it is important that if you do drag a texture onto an object and the texture looks like this, so it looks completely out of sync, that's because the size value most likely is not 1. So come into size and make sure that it's set to 1 as its default value. So now we have a nice box asset. I can hold on Alt, duplicate this, maybe scale it up, and even drag it from the content browser. But now we do have an issue, and that is when we drag a box from the content browser, it does not have the material we just created. So to set our box's default material, we need to open up the asset static mesh editor. And within here, we see that we have a default material slot. Right now it's using the world grid material. We're going to set this to mi_wooden like that, press save. And now that material is applied to all our boxes, even when we drag out a brand new box. Before we move on to the next chapter, I think it's important to point out what this texture right here does. So I'm going to double click on it, and this texture does look a little bit weird, but essentially what it is that it combines several different masks into one texture using the RGB channels. And I know that might sound confusing, but essentially in computer graphics, color is made up of a red channel, a green channel, and a blue channel. So what developers realize is that they can take these individual channels and then hide masks inside of them. So for example, if we uncheck the blue channel and the green channel, we see that the red channel of this texture is our metallic mask. Uncheck red, check green, our green channel is roughness, uncheck green, and check blue. Our blue channel is ambient occlusion, although we won't use ambient occlusion. I included it within the texture to show that we can hide 3 different masks inside a single texture. And because even though this is a color texture, it's actually going to be used as masks, we want to uncheck sRGB right there. So the way we would use this in a material is let's create a brand new material, call this one mask example, and double click to go inside of it. So if we were to create a material from this mask, I'm going to drag out our base color in our normal map, because of course we still need them. And instead of using our metallic or our roughness texture, we combine those into one individual texture right here. So we don't need those since they're combined into this one. And our red channel is metallic, so I'm going to grab from the R pin into metallic, and our green channel is roughness. Now roughness didn't have to be the green channel, it could have been blue or red, just I decided to use the green channel. And if I press apply, inside of our map, let's apply the new material to this crate. And right now there is a slight difference between the two, since in the material instance, I am using color tint. So reset that back to white, and jumping back here, we can see that there's virtually no difference in between combining the textures or using the textures separately. So I included it within this course because it's pretty important to know why Unreal developers use this, since you will be seeing this a lot. Also, it's good to know exactly what these R, G, and B pins are used for. That is how you create Unreal assets, but you're probably wondering now, how do I move Unreal assets in between different Unreal projects? Because it would be a real shame if every time we create a new project, we have to remake all the assets. And we can move assets in between projects through an easy process called migration. So to migrate assets in between 2 Unreal projects, of course we need a new Unreal project. Included within the downloadable content, link in the description below, is a project that contains some assets I want to bring into our first project that we've been working on. So within the zip file, go into it, and it's specifically intro Unreal project. So just drag it onto our desktop to unzip it, and double click to go inside of the project folder. To open up an Unreal project, double click on the .u project. Now that I have the downloaded project open up, if I press Ctrl and space, we can see all the content that's currently inside of it. Now, if your content folder is empty, then that means you didn't unzip the project. So make sure you do unzip the project before opening it up. So I have a folder called Lighting Examples with some maps, materials, meshes, and textures that are going to help us demonstrate Unreal's lighting capabilities. I don't want to bring all of these assets into our original project called First Project. So to do so, I'm going to dock them to the sides of my screen. And let's go open up our content drawer. So what I'm going to do is copy our lighting examples folder, which is right here, and bring it into another project. To do so, we use a process called migration, and migration is really simple. Simply hover over the assets you want to bring into another Unreal project, right-click, and select Migrate. Now it's going to give us a list of all the assets that are going to be migrated, and this all looks correct. So I'm going to click on OK. And now it's asking for a location to migrate them to. We specifically want to migrate them into the content folder of the destination project. And you can find out where the content folder is by double-clicking on the original project file. So right here is first project, which is where this project is stored. And if I go into its project file, we see that there's a content folder, and this is the location that I want to migrate all these assets to. So I could go through and manually navigate to this location, or I can copy its destination with Control-C and Control-V it right here. So now I have the content folder of our original project selected. I'm telling Unreal that I want to move the files from Intro Unreal project to first project. And click on select folder. So now we can see content migration successful. And if I go into first project now, press Control and space, under content, we now have lighting examples, which are all the same assets from our downloaded project. Now an alternative, that's so we don't have to go and find where our project file is located. In order to get the content folder's location, I could press Control and space to go into the content drawer and right click on our content folder and go show and explore. This will automatically bring up the content folder from our project. Finally, let's talk about Unreal Engine 5's brand new lighting system called Lumen. And Lumen is revolutionary because it gives us real-time global illumination. And essentially, global illumination is just a very fancy term for light bounce. Because in real life, light doesn't just hit an object and stop. Instead, it hits an object, bounces off that object, and after each bounce, it illuminates the world. It also takes a little bit of that object's color and projects it onto the next object. For example, it might be a little bit hard to see because the video is being streamed, but here we have a red mouse, and light is hitting this mouse, taking a little bit of its color, and then projecting it onto any nearby objects. So if I move the mouse to the table, around the table, there's a little bit of a reddish tint that's coming from the bounce lighting. So global illumination is important because it's the secret to realistic rendering. But there's one large problem, and that is global illumination is very expensive to calculate. Real-time global illumination isn't possible without a super powerful GPU. And this is where Lumen comes in handy. Lumen is a brand new way to render global illumination at the fraction of a cost compared to traditional ways to get global illumination like hardware ray tracing. So to show Lumen in action, let's jump back into Unreal. And to do so, we need the content that we just migrated over. So if you haven't already, make sure you download the lighting examples, link in the description below, and migrate it into our project from the previous chapter. So to begin, let's go to Maps and Light Bounce. So as we can see, this is an insanely simple room. All we have is 4 walls and 2 objects and a light source. I've also gone ahead and added in a post-process volume. Since by default Lumen is turned on, I want to turn off Lumen to demonstrate how we used to get global illumination back in the Unreal Engine 4 days. So as we can see, global illumination method is set to none. Now let's just pretend that we're in Unreal Engine 4 and I want some global illumination since obviously shadows are never this dark. Normally you would see some light bouncing around to illuminate the shadow areas right here. So the first thing I would do is number 1, make sure my light sources are set to static, not movable. And number 2, I need to build my level. And to build, you want to come up to the Build tab all the way up here, select it, and within the dropdown, simply select Build All Levels. Right now, behind the scenes, Unreal is ray tracing our entire level and creating a light map. This light map contains all the lighting data, which it then overlays onto our world as a texture. Now we are done building our lighting. It should have been pretty quick because this is a very small level. And if we look at our level, we can see that we do have global illumination. Notice how this sphere is no longer pitch black in the shadow areas. There's now light filling up the shadows, making it look a lot more realistic than beforehand. We can even see that there's some red on the sphere that's bouncing from the red wall. Same thing over here. The entire room has a little bit of a greenish tint since this green wall is also bouncing light off. So this is how we used to get global illumination in Unreal Engine 4. And while this is great, there are some major issues. Mostly that our lighting and all our shadows are static. So if I select my sphere and move it around, we can see that the lighting breaks. Press Ctrl Z to undo that. Then even if I select my light source and move it around, the lighting also breaks. Notice how if I move my light away, we now have two shadows. So there's one shadow that's coming from the light source and another shadow that's coming from our light map, which is no good. So I'm press Ctrl and Z to put our lighting back at the original spot. And this is where Lumen comes in really handy because it allows us to have dynamic global illumination. So I can move my light around and move my sphere with no issues whatsoever. But first, we have to get rid of our light map since we did bake our world. To do so, you need the World Settings tab. Now, by default, there is no World Settings tab. We can get that by coming up to Windows and selecting World Settings all the way down here. And now we have our World Settings. As you can guess, World Settings is simply the settings of our world. So this is where we would control our light baking. And we will go over light baking settings in just a bit. But for now, I want to get rid of our light maps by selecting Force No Pre-Computed Lighting, which will tell Unreal that I don't want to use any light maps and I don't want to build our lighting. And then after I set that to true, make sure you press build. Now that didn't build our lighting. Instead, it went through and it got rid of all of our light map textures. So let's come back to details. And now I'm going to set my light source to movable. So now that it's set to movable, we still aren't getting any global illumination because if you remember in the post-process volume, I turned off Lumen. So let me zoom in a little bit so that we can see this better. Here is Unreal Engine 5 without Lumen, and here is Unreal Engine 5 with Lumen. So this is without, and this is with. And what's amazing is that I can move this light around, and there are no issues. I can even move this sphere and make it bigger, smaller, and Unreal is calculating all this global illumination at a very smooth frame rate, which is absolutely amazing. This was not possible in Unreal Engine 4. So if I grab this light, and even if I move it all the way over here, we can see that there's bounce lighting coming from the light hitting the wall, and then bouncing and hitting the sphere, giving our entire sphere a little bit of a reddish tint on the right side, which is very realistic. We could even come into the point light settings and gives ourselves a softer shadow by increasing the source radius. So if I increase this, notice that the shadows get softer and softer. Global illumination used to be pretty expensive since you'd have to use hardware ray tracing, but now, thanks to Lumen, it's accessible to everyone, while running at a smooth frame rate depending on your computer. And something that was not possible in UE4, even with hardware ray tracing, is that if I come into lighting examples, materials, and use M_emissive material, our emissive materials give off light. So I'm able to light up a scene by just using our materials, which is really amazing. So I'm going to press Ctrl and Z to undo those, since now it's time to go over all the different light sources that Unreal Engine has to offer. So to begin, let's talk about the point light. So I'm going to delete it, and to get a point light, you want to come up to the Add button, of course, and under Lights, drag in a point light. So the point light is the most basic of lights. It's just a point that emits light in all directions. So let's go over the most important settings in the details panel. And probably the most important one right now is intensity. So it's at 8 candelas. I can bring this down to 1, 2, or even something insanely large like 100 to change the power of the light source. But for now, I'm going to leave this at 4. We also have the source radius, which I just went over. But if we increase it and make sure that you do have game view turned off up here, you can see that there is and hopefully you can't see this a little bit better with the red background. We have the outline of a yellow sphere. And this sphere basically tells us the size of our light emission. And the larger our yellow sphere is, then the more soft our shadows will be. And as I decrease this all the way back down to its default of 0, we get some really harsh shadows. So if we want to soften that up, bring up the source radius. Now right below that, we have temperature. So temperature allows us to change how warm or cold our light source is. If I bring this down, our light source gets warmer and warmer. And if I bring this up, it gets colder and colder. And I can disable temperature by clicking on the temperature button. And all the way down here, we have light color. So as you can guess, light color just changes the color of our light. The controls are exactly the same as our materials. And above all these is the indirect lighting intensity. So right now it's set at 1. When I set it to 0, we're going to have very little bounce light, and our shadows end up like beforehand where they're pretty dark. Not much bounce lighting is happening. Or instead of 1, which is its default, I can bring it up to 10, and now we have a lot of bounce lighting. So I'm just going to leave it at 1 for now. So those were all the main settings for point lights. I'm going to delete that, and let's go over the next light right now, and that is the spotlight. The spotlight is very similar to the point light, although unlike the point light, the spotlight is just illuminating one direction. And you could change the direction the light is pointing by, of course, rotating it. The settings are the exact same as the point light, except we have an inner and outer cone angle. So the outer cone angle will control the size of our spotlight, and the inner cone angle will control the fall off of our light. So I'm going to go to game view mode so we can better see this. And as I increase the inner cone angle, we can see that our lighting gets sharper and sharper and sharper. And if I decrease it all the way to 0, there's a very soft fall off. So those are the controls for the spotlight. I'm going to delete that and go into the next one. And that is the rectangle light. So rectangle light is pretty similar to the spotlight and directional light, except now we're emitting from a rectangle pointing in a specific direction. Hopefully you can see the outline of the light when it's against the wall. And I control the size of the rectangle by going into source width and increasing the width, or I can increase the height. I can even, just like beforehand, play with the fall off by decreasing the barn door angle from 88 all the way to 0. And hopefully you can better see it from this angle, what the barn door is. Or I can increase the length. So we have a lot of control over the specific fall off of that rectangle light. Other than that, the controls are the same. So let's delete that. And next up is probably the light you're going to be using the most, the directional light. So we don't see anything with the directional light right now because I have to rotate it to see what it does. And as you can guess, this is the sunlight. So the sunlight is pointing in a specific direction infinitely. And just like the spotlight, if I rotate this around, I'm able to control the direction of our sun. The directional light has pretty much the same exact controls as our point light, except if I zoom in on the shadows, we get source angle. Bringing up the source angle makes the shadows smoother, and bringing down the source angle makes the shadows sharper. So I'm going to reset its value by clicking on the arrow icon, and I'm going to delete our directional light since there's one last light I want to show, and that is the skylight. So let's drag in the skylight, and you'll notice nothing is happening. And the reason why is because the skylight is pretty unique. Essentially what it does is that it captures our sky and then it projects it onto our world. And right now our skylight isn't doing anything because obviously our world doesn't have any sky. So the way we can add sky is pretty simple in Unreal Engine 5. You just want to come up to the add button, come all the way down to visual effects, and drag in a sky and atmosphere. Simply place it right there. And again, if I look up, we don't have any sky since the sky requires a directional light, which is the sunlight. So let's also come up to add, down to lights, and drag in a directional light for our sky. Now, if our skylight isn't working, then it has to be refreshed by going into the details panel and turning on and off effects world. Now, the reason why I know the lighting in our room right now is from the sky and not from the directional light is because the directional light is not hitting the inside of our room. So if I move it around, then we can see that our directional light is illuminating our room. But if I move it, that's how it's coming from the back. The lighting is entirely coming from the skylight. And we can see this better by hiding and unhiding the skylight by using the effects world right there. So here the skylight is being used and here the skylight isn't. So this is without skylight and this is with skylight. And something that's pretty cool about the skylight is that if I add in a cube, so let's come up to shapes, cube, drag that in, scale that up, we can make a makeshift door. And now notice how as I move my cube, the skylight slowly starts to illuminate our room. So that's why the skylight is a pretty big deal, since it allows us to capture our sky and project it onto our world as Lumen lighting. And finally, it's time to go over Lumen settings. So these are settings that affect all of our Lumen lighting before we move on to lighting and environment, completely from scratch. So I'm going to delete everything. And I'm just going to add in a simple point light once again, because I want to show and also decrease the intensity to 4. And this is probably something you've noticed, is that there is a lot of noise, especially in the shadows. Now, I don't know if it shows up due to the YouTube compression, but if you are following along with the tutorial, you can see a lot of that noise. And to get rid of that noise, we need to play with the Lumen settings, which are located in our post-process volume. So find out where your post-process volume is. As a reminder, you can create a post-process volume by coming up to Add, Volumes, and Post-process volume. And make sure in your post-process volume that Infinite Extent Unbound is turned on, because otherwise our post-process volume will not be affecting our entire world. So you want to come down all the way inside the post-process volume to Global Illumination, and by default, Lumen is turned on. And we get a bunch of Lumen settings under Lumen Global Illumination. So first off, to get rid of that noise, check Final Gather Quality and increase it from 1 to 4. Now we can see that noise slowly start to disappear, and there is a lot less noise. We can even increase this to 10, and now our scene definitely looks a lot better. So if we hover over any of these settings, it gives us a very quick description. While Final Gather Quality does get rid of the noise, it also comes at the cost of GPU. So just keep that in mind, that if you do increase Final Gather Quality, you might lose on some performance. There are also some other settings, which I'm going to go over in the next chapter. That's the basics of lighting in UE5. Now we're going to take the knowledge that we just learned and apply it to lighting an architectural visualization scene. First, we're going to light the environment by using Lumen and movable lights. Then we're going to light the same exact environment, but with static and baked lighting. So we're going to compare the two methods of getting global illuminations and see their pros and cons. The specific architectural environment is already included within our lighting examples that we migrated into our first project. We can see under lighting examples maps, it's the map that's right next to the map that we've been editing, which is light bounce. So let's double click on Archviz room, and we won't see anything because there are no lights. If I press Alt and 3, or if I click on unlit from the view mode, that this environment is just a simple room with some furniture and a window from which all our light is going to come from. So a very simple room, which will help us learn and get the gist of how to light a scene in Unreal Engine. I'm going to press Alt and 4 as a shortcut to go back into our default view mode. Now the first light I'm going to add in is the main light, which is the sun. So let's add in a directional light, and I'm going to rotate it so that the sun is coming through the window. And already, especially right here, we can see global illumination and Lumen at work. So I want to find a nice angle. I think right there is pretty good. But if we look outside, there is no sky. It kind of looks scary just seeing an endless black void. So let's add in a sky by coming back up here to visual effects and the sky and atmosphere. So drag that in. But half of our world, the bottom half, is still a black void. We can hide that black void with fog. So come back up to Add, Visual Effects, and below Sky and Atmosphere, we have Exponential Height Fog. Simply drag that in. And now if we look outside the window, all we see is sky, which is what I want. But there is a little bit of an issue, and that is if we hide and unhide the Exponential Height Fog, we can see that there is a little bit of fog inside of our room, and we don't want that. So within the Exponential Height Fog, one of the settings we're going to change is right here, Start Distance. I'm going to drag this all the way up to its max of 5,000. So essentially, Start Distance is saying, do not use fog until we're 5,000 centimeters away from our camera. So now if I hide and unhide it, we don't have any fog inside our room. There is one more light that I want to add to our room, and that is the skylight. So let's come to Lights, Skylight, and drag it in. So we can already see that our room got a little bit of a bluish tint from our sky. I can hide and unhide it right here. So Effects World, turn it off, and turn it back on. So we can see that it does make a little bit of a difference. So I'm going to set the skylight to movable and also set the sun to movable. Since both of these lights are being used with Lumen, we aren't baking any lights. And another thing I'm going to do is add in a post-process volume. Since if we come over here, and I don't know if it's noticeable in the YouTube video, but there is a little bit of noise. So we can get rid of that by adding in the post-process volume. Simply drag it in and make sure you scroll down And infinite extent unbound is turned on, so we don't have to be in the post-process volume for it to take effect. Now let's zoom all the way up to Lumen Global Illumination. And right here for final gather quality, instead of 1, I'm going to set that to 10. And a lot of that noise just disappeared. Also, I want to add some soft shadows to the really small objects, since right now there is no soft shadow that's being given off from the phone, the clock, or the coffee mug. So the reason why is because I have to increase the Lumen scene detail right here from 1 to 4. So this was beforehand at 1, and now this is 4. So by default, to save on processing power, Lumen excludes a lot of small objects from its calculations. So you need to tell Unreal that you want them within the Lumen calculation by increasing it from 1 to 4, or even higher if you do have smaller objects. And one last edit I'm going to make to the post-process volume is setting it for a manual exposure. So under exposure, metering mode, set to manual. Bring up the exposure compensation to 13.25. It's pretty good. And also, this is an artistic choice. If we increase it, we can see that we get more bloom in our world. So maybe a value of 2. So this is without bloom and with bloom. I do think it makes the scene look a little bit nicer. And that is the basics of lighting and environments in Unreal Engine 5, specifically for architectural visualization. And since we're using Lumen, that gives us the ability with Control and L as a shortcut to rotate our sun, watch our world be updated in real time based off of our sun's lighting, which is pretty insane. Now, while Lumen is amazing, we do get some trade-offs in quality. Just because we are able to use real-time global illumination doesn't mean that it's the best case for certain scenarios, specifically a scenario like this, where there isn't going to be any moving parts since it's just an architectural visualization scene. We might as well bake our lighting because number one, baked lighting is always more performance friendly than using Lumen because Lumen does do a lot of GPU calculations behind the scenes, while baked lighting is just overlaying a texture. And number two, if you properly bake your lights into a good light map, then the quality will be better than Lumen. So let's convert our Lumen environment into a baked lighting environment. So I want to make a copy of our current level, which is Archviz room, by selecting it in our content drawer and pressing Ctrl and D to duplicate it. So let's call this one Archviz room baked and double click to go inside of it. Make sure we save selected. All right, great. So first thing I'm going to do is select all my lights and set my directional light to static and set my skylight also to static. Now I'm going to go into my post-process volume and disable Lumen for reflections and global illumination. So set this to none, and under reflections, also set this to none. So we can see immediately we aren't getting any global illumination. That's because I should come up to build and build all levels to start ray tracing in the background. All right, great. So here we have our baked lighting. This is really bad since we need to increase the quality of our light bakes by going into the world settings. And if I scroll up, we can see that under light mask, we have light mask settings. And in the dropdown, we have a bunch of settings that will change the quality of our light baking. So first thing, I want to increase the number of bounces, which will just illuminate our scene a little bit more. So the number of indirect lighting bounces is right now set to 3. Let's set that to 10. And also for sky lighting bounces, set this from 1 to 10. Number 2, for static lighting level scale, if we bring this below 1, for example 0.5, then we're going to get a lot more quality out of our bakes. So I'm going to set this instead of 0.5, let's set this to 0.1. And to compensate for the static lighting level scale, you want to increase the indirect lighting quality to 10. So specifically, I want to increase the indirect lighting quality to 10 because the static lighting level scale right now is set to 0.1. And generally, you want your static lighting level scale times your indirect lighting quality to equal 1. So for example, if instead of static lighting level scale being 0.1, I change it to 0.5, then the indirect lighting quality should be set to 2, since 0.5 times 2 equals 1. But I'm going to leave it at 0.1 since that does give us a better value at the cost of waiting a little bit more for the ray trace calculations to happen. And now that I like my settings, come to build and click on build all levels. So this build will take longer than beforehand because we increase the quality of our light bakes. So now this is our scene, and we didn't really notice that much of a difference since I also want to come up to build and under lighting quality, make sure that it's not set to preview. Instead, it's set to either medium, high, or production. I'm just going to set to medium. And also while I'm at it, I'm going to select my post-process volume. And let's bring down the bloom, since I think the bloom is too intense, to 1. And for exposure compensation, I'm going to leave it at, let's go 12.7. And now if I press build all levels, keep in mind that if you are following along exactly with this tutorial, you do not have to press build whenever I press build, since I'm building my lights a lot more frequently than I would to just demonstrate what some of these settings do. So if you want to save time and not have to wait for each build, then I would wait for the very end and copy those settings. We can see that the quality is still not the best. Because if you remember, light maps are being baked into a texture. And if that texture has low resolution, then we're going to get low resolution shadows and lighting. So we need to raise the resolution on each of our static meshes. And to see the resolution of our static mesh visually, you can come up to Lit, down to Optimization View Modes, and select Light Map Density with the shortcut Alt and 0. So right now, our entire room is pretty much blue. This is not what we want. We want our scene to be in the greenish to reddish range. So to increase the light map resolution of a static mesh, you want to select the object, and within the details panel, scroll down until you see lighting and overridden light map resolution is at 64. Turn that on and increase that to, let's try 128 or 256. And okay, that looks a little bit better, but since this is the floor and it will have some of the shadow, I want to increase that to 512. So make the floor pretty dense. I think the walls around it should also be, let's go 512, and the roof can also be 512. So for the baseboard, I'm going to select that and make this, let's try 256. The door needs to increase it from 64 to 128. The chair is a pretty big deal since it's our focal element. So let's go 256 right there. And for the wall, is at 256. I'm going to try 512. The table is at 128. Actually, let's make this 512. The wall right here, 512. And the floor, actually, I'm going to increase this to 124. So I think this looks good. Now if we bake our lights, let's see what this gives us. So at this point, it is going to take a little while for our lights to bake, since there's a lot more detail it needs to calculate. And probably by now you understand why Lumen is a pretty big deal, since it gets rid of this repetitive process of having to wait for our lighting to bake. And then if we don't like the bake, we have to change something and change some settings and then bake our lighting again. And then if we don't like that, we have to go back, and it's an entire process, while Lumen just works immediately. But in this case, it is worth it since the quality is going to be better than Lumen. Okay, now that we're done baking, let's see what our world looks like. And okay, that's a lot better. But the shadows, especially in between objects, are a little bit too intense, since by default Unreal is calculating ambient occlusion. I want to disable ambient occlusion since I'm just relying on our baked light map to simulate all of our shadows and lighting. So within our post-process volume, let's go find where ambient occlusion is, which is right here under rendering features, under ambient occlusion, intensity. Let's turn that to 0 to turn it all off. And increase our exposure compensation to 13. Okay, now our scene is baked, but we are missing one last thing, and that is we don't have any reflections whatsoever. Our world looks pretty bad since we don't have those reflections. And the reason why is because Lumen calculates reflections automatically. When we bake our lighting, we have to specify where we want our reflections to be. And we do that through a sphere reflection capture. So to add a sphere reflection capture, come up to the add button, down to visual effects, and drag in a sphere reflection capture. Essentially what the sphere reflection capture does is that it takes a 360-degree snapshot from the sphere of our world, and then it uses that as the projection of our reflections. And to get a better snapshot of our world, come up to Build and select Build Reflection Captures. So right now we have one reflection capture, but we can have multiple reflection captures since obviously it doesn't make sense for all reflections to grab from the same location. So if I duplicate this with Alt, and then if I decrease the influence radius within the details panel to, let's go 500, and place it on top of my small objects right here. And once again, come up to Build and Build Reflection Captures. We can see that these objects, instead of grabbing from this sphere reflection capture, they're grabbing from the smaller one, which is overriding the larger one. Since the reflection capture on the table is smaller, Unreal knows to pick this sphere reflection capture for all the objects within its radius of 500 centimeters. So this is essentially how you bake lighting in Unreal Engine. Now I know that the setup took a lot longer than using Lumen. Also, we have to wait a while for each light baking to happen and for all the light maps to be created and the ray tracing to happen. But in the end, in my opinion, the quality, especially right here, if I select a chair and hide it, we can see how detailed those soft shadows are. And if I unhide it, take a good look at this baked lighting scene, jump back into our Archviz room, which is using Lumen. Obviously, the baked lighting looks a lot better. So hopefully you understand the difference between baked lighting and Lumen, their pros and cons, and why you would use baked lighting over Lumen, even though Lumen is real time. That is the very basics of lighting in Unreal Engine. Of course, you could get even more complicated because the lighting is an entire art form by itself. But hopefully you do have a good foundation to learn more. Now we're going to go over landscapes. So landscapes in Unreal are pretty important because odds are you will always be seeing a landscape or your character is on top of a landscape. So in this section, we're going to go over how we could create a landscape, sculpt it, and finally at the end, go over how to add foliage. To demonstrate how to make landscapes, let's create an entirely new map. So press Control Space and let's go into My Stuff. And right here, let's create a brand new folder called Maps, which will hold all of our maps. So I'm going to select both my map and my build data and drag it into Maps, let go, and move here. So let's jump into there and right click, create a brand new level. So by right clicking and creating a level, instead of coming up to File and New, we don't get access to the templates, which is fine. I do want to create a brand new level completely from scratch. So let's call this one Landscape Example and jump in. So let's save everything. The reason why we're starting from a blank level is because I want to show how to light an outdoor environment from scratch. Okay, to begin, let's create a landscape. To create a landscape, you need to go into landscape editing mode. To do so, come up to select mode and then select landscape. Finally, we're going to go over what some of these modes do. So you can press landscape, or the shortcut is Shift and 2. So throughout this tutorial, so far we've been in select with the shortcut Shift and 1. Now we're going to go into Shift and 2 to edit our landscape. We don't have a landscape, so Unreal is going to ask us if we want to create a landscape. We see that we get a bunch of different settings that we can pick from. Generally, I don't play with these settings, I just leave it as default. But if you are going to play with those settings, I recommend you use the templates provided to you from the Unreal documentation. Type in Unreal Docs, and then type in Landscape Technical Guide. So if you are going to change any of these settings, I recommend you use the presets. For now, I'm going to use the default settings and press Create. Okay, great. Now we have a landscape, but before we start editing our landscape, it's best to light our scene so we know exactly what is happening. First off, let's add in a directional light. So add light directional light. Simply drag that in. We can leave all the settings at default, except I'm going to set to movable since I want to use completely dynamic lighting. To help us know the direction of the light and how the shadows will look like, I'm going to add in a cube temporarily to help us when we're lighting our scene. Just like that. Now, obviously, we don't want an endless black void. We want a sky. So come up to Create, Visual Effects, and select the sky and atmosphere to drag it in. And automatically it's working. If I hold down Control and L as a shortcut to rotate my sun, notice that the sky updates in real time. So as I lower my sun, the sky changes colors to represent a morning time or a dusk time. And I can raise it up to get a more bluish sky, which is pretty amazing that Unreal automatically updates your sky depending on your sun's angle. Now there are two issues. We still have a black void in the lower half of our world, and zooming in on the shadow, it's pretty dark. We're getting a little bit of global illumination and bounce lighting from our sun, but we need lighting from our sky as a whole. So to fix that, come up to Add, Lights, and drag in a skylight. Now it's recommended for skylights that under real-time capture, make sure it's turned on if you are going to use a skylight with the sky and atmosphere. And also, while we're at it, set it to movable since we're only using lumen lighting. Also, let's go fix our black void by adding in some fog to cover that. So come into Visual Effects and Exponential Height Fog, simply drag it out like this. And we can control where the exponential height fog starts by moving the widget. So if I move it up, we get more fog, and if I move it down, we get less fog. So hopefully you can see what's happening. For now, I'm going to leave it in the middle right here. And with that, a directional light, sky and atmosphere, skylight, and fog is pretty much how you light 90% of open world scenes in Unreal Engine 5. It is literally that easy. And what's amazing is that all these objects interact with each other successfully. So I can move my sun around, lower it, create a really dark area, lower it to the point where it's night, and then raise it. Slowly the sun comes above the fog and starts to illuminate our world. So it's completely real-time, time of day lighting. Now that we set the lighting, we're able to see any edits we make to our landscape. So let's finally go over the landscape editing mode. And to do so, I need to come up to my mode selector and select landscape from select, or I can press Shift and 2 as the shortcut. So by default, it's going to give us this brush right here. And as you could probably guess, hold down the left mouse button, I'm able to sculpt and raise the terrain. So left mouse button is to raise the terrain. If I hold down Shift and left mouse button, then I lower the terrain. And by default, we are using the basic sculpt brush. I can even increase the tool strength. So right now it's at 0.3. Of course, if I bring it up to 1, then our sculpts will be a lot more intense. Even holding down Shift, I can really lower the landscape's terrain. If I want to, I can control the fall off of this brush with the brush fall off. So bringing it to 0 will mean there is no fall off. So I get some insanely harsh sculpts happening. Or I can bring it all the way up to 1, which makes the fall off non-existent, giving us the smoothest brush as possible for really faint changes to our landscape. Now, a shortcut to increasing the brush size is to use the right bracket key on my keyboard. So right bracket key will increase my brush size and left bracket key will decrease it. Very similar to Photoshop shortcuts. So that's the basics of the sculpt brush. As a reminder, if you ever want to get back the default values of any property in Unreal Engine, go to that property and select the arrow right next to it to reset it back to its default value. Now let's go over the smoothing brush. And as you can guess, if you have some really harsh landscapes and you want it to be smoother, like right here, it was really harsh since our fall off was non-existent. Using the smooth brush, I can smooth away those bumps in the landscape. So pretty great. And the next brush after that is the flatten brush. So flatten brush is great for terracing, or maybe you're creating a game, for example, and let's say right here you need a flat area for your gameplay. Well, to get a flat area, of course, we need to use the flatten brush, which will just flatten our landscape. It's also great for creating terraces. So if I start my flatten brush off right here, notice how we have a higher terrace and a lower one. And right below that, another one. So we're very quickly able to create some complicated landscapes with just these 3 brushes. And these 3 brushes are the main brushes. Generally, I don't really touch any of the other brushes, except for very specific circumstances, which we aren't going to be going over in this video. Now, that's how you sculpt a landscape. But how do I paint a landscape? Since right now we're using Unreal's default material, of course, landscapes in real life are not made out of squares. Instead, they're made up of grass, dirt, sand, rocks, and pretty much anything you would expect outside. Now, I'm going to briefly go over how to create a very basic landscape material. Create the material under My Stuff, and call this one M_landscape. Double click to open it up. And I'm going to dock it up here so I can switch in between my level and landscape. Now the difference between a normal material and a landscape material is one node, and that is landscape layer blend. So select it, and here we have the layer blend. Notice how we don't have any inputs. That's because we need to specify inputs in the details panel right here. So the inputs are essentially going to be layers. So you can have a grass layer, a dirt layer, a sand layer, and then within your landscape editing mode, we'll be able to paint on those individual layers on our landscape. So to add in a layer, select your layer blend, and under layers, click on the add button, and make sure you click on the triangles to see the drop down. Now for the first layer, call this one grass, and the second layer, call this one dirt. Now this is just for demonstration, so it's not going to look very good. But to get the point across, let's go find a grass texture and a dirt texture under starter content, textures, and I'm going to use T_ground. Also for dirt, looks like we don't have a dirt, so I'm just going to use the metal rust texture because that does look like dirt and it will get the point across. So drag in metal rust as our dirt. Now hook up grass right there and dirt, and I'll put these into base color, and let's press apply. Save everything, jump back into landscape examples, and now to apply the landscape material to our landscape, we can't just drag our material onto the landscape like that. Instead, in the details panel, scroll down and get landscape material and drag on the landscape material to the slot right there and let go. But we get a really weird black texture since we need to specify where these layers are. Right now, Unreal isn't picking any layers, so it's just defaulting to black. Hop back into your landscape mode by pressing Shift and 2, and within Paint, we have our layers. So we need to create our layers and store them somewhere within our content drawer. So to create a layer, click on the Add button, and you want to select Weight Blended Layer Normal. So select that. It's going to ask us to create a new landscape layer info, and it's going to automatically create a new folder for us where our map is located called our map name and shared assets. Now we could also create a new folder by right clicking and going new folder, or we could pretty much save this anywhere else in our project, but I'm just going to leave it as default value and also leave it at the default name it's generating, which is grass_layer info. Click save. Now we have our layer right there, and we can see our grass has been applied to our landscape. Let's do the same thing for dirt by clicking on the plus button and going Weight Blended Layer Normal. Select that, and for dirt_layer, also click on save at the same location. So now we have two layers in a folder that's right next to our maps, and go to save all. Now obviously this landscape is too shiny, so jump back into M_landscape, hold down 1 and left click to bring a constant scalar parameter and give a value of 1, so we have complete roughness to get rid of that shine. Press apply, and our landscape is looking better. But I also think we should add in normal maps to give the texture a little bit of bump to it. So come back into our landscape material and press Ctrl and space under textures. So starter content, textures. Let's find where the grass is, which is right here. Drag out a normal map, and let's find where the normal map is for rust, and that is right there, and drag that out. So I want to blend between our normal maps, just like how we're blending between the base colors. And I could do that by copying and pasting my layer blend, which I can do with Ctrl and D to duplicate, and plug up the normal map right there, and plug up the rust normal map right there, and put those both into normal. So now we have two layer blends, which are sampling from the same exact layers that we just created in our landscape editing mode. And press apply. Now let's jump into dirt and lower the brush size just a little bit. See, the tool strength is at 0.3. Holding that left mouse button, I'm now able to blend in between dirt and grass. One thing I like to do whenever I'm creating my landscape is to get a human reference. That's why I'm able to compare the size of my landscape next to a human, and this is especially helpful since one thing I want to do with M_landscape is add in texture tiling, but it's hard to know how much I should tile this texture when there isn't a human reference. So to get a human reference, you want to come up to add and add feature or content pack and select the third person. We can see that there's a mannequin right here, which we're going to be using as our reference. and select Add to Project. So this will add a bunch of new assets to our project. And specifically, I want to use the assets in character, mannequins, meshes, and we can do skm_Manny. So drag that out to get a human size reference to compare our landscape textures to. And we can place them right there. So this human, if I zoom in on the grass, we can see that probably the grass is a little bit too small. So let's fix that, jump back into our landscape material, and the way we change the tiling of any textures is the exact same way we did with m_master material. So we grabbed the texture coordinates and we multiplied it by a parameter value so we were able to edit it in the instance of this material. Now I could recreate this from scratch for m_landscape, or I can highlight all of that, press Ctrl and C, go back into m_landscape, and Ctrl and V it. Now I can plug this up to grass, and also I want to plug this up to the normal map of grass, which is right here. So if you remember, both this texture and this texture handle grass, since they're both being fed into the grass layers of the layer blend node. So press apply, and we won't notice any changes since we have to create a material instance of our landscape and apply it to the landscape. So right click, go create material instance, and drag this material instance onto our landscapes with the landscape selected. So just do that, and then double click on our instance. Let's undock it and bring it into the maps right there. Click on size, and I want to increase the size of my texture by decreasing the tiling. So instead of 1, let's try 0.5. Okay, that looks better. Maybe even 0.3. Okay, I really like 0.3. So this was beforehand at 1, and now this is the tiling at 0.3, which makes the landscape look better. Now I also want to add in tiling features for our dirt. So I can highlight this, press Ctrl C, Ctrl V, and paste it right there, and plug this up to dirt, and plug this up to normal map. But if I press apply and go back into our material instance, we have a pretty big issue right here. And that is, now our size controls both, and let's come over to the dirt, controls both our grass and dirt. And we want to control those independently. And the issue is in Unreal for material parameters. If you have two parameters with the same exact name, then they're going to be treated the same within the material instance. So the way you fix this is that you have to give each of these parameters a different name. So call this one size grass, and then call this one down here size dirt, and press apply. And now that should be different. So we also get the dirt parameter within our instance. So let's jump back into landscape example and press Shift and 2 to go into landscape mode. Select dirt because I want to paint a little bit of dirt right next to the mannequin so we can see what grass and dirt look like in relationship to our human scale reference. Now with dirt right there, let's go increase it to 0.3, maybe even 0. Actually, I think 1.2 looks good. So just a little bit more tiling with our dirt. If you are curious how to make a really good landscape material, I do have a landscape tutorial series on my YouTube channel. While it is for Unreal Engine 4, pretty much all of it still applies to Unreal Engine 5. That was the very basics of landscapes. Now we're going to go over how we can get assets from the Megascans library. So in case you don't know, Unreal already comes with thousands of free high-quality assets ready to be used immediately in Unreal Engine. We can get these assets through the Quixel Bridge plugin, which is already installed in Unreal. Before we jump into Megascans, let's make some edits to our world. So first off, I'm going to get rid of my landscape material since I think it's a little bit distracting and I just want to focus on the Megascan assets. So select my landscape, scroll down to the landscape material slot, and let's reset it back to the world grid by selecting the arrow right there. There we go, and I also want to lock my exposure with the post-process volume. So come into volumes, post-process, drag it out, and scroll up to exposure, Let's set it to manual and exposure compensation. Notice that there is no change right now because I need to make sure that infinite extend unbound is turned on. Now I can increase the exposure compensation. I found a value of 12 to be pretty good. And I'm also going to raise the position of my sun so we get more light in the world. Okay, so now that the sun was raised, notice that the brightness of the sun also increased. So exposure compensation, I'm going to lower it to 11 or 11.5. All right, great. So let's go over how we can get access to the Quixel Bridge library. And getting access is pretty simple. You just want to come up to the add button and then select Quixel Bridge. Now, if this is your first time logging into Quixel Bridge, it might ask you to log into your Epic Games account. Don't worry, it's the same exact account that you created when downloading Unreal Engine. So just go into that, and then you get access to, right now at the time recording, 16,688 assets, which is absolutely amazing. Now, if for some reason you don't have Quixel Bridge installed in Unreal Engine, then you want to go to the Epic Games launcher and come to Unreal Engine library, scroll all the way down to Vault, and find the Quixel Bridge plugin. Once you found the Quixel Bridge plugin, click on Install to Engine and select Unreal Engine 5. Although by default, this plugin should be installed, so you shouldn't have this issue. But it's important to bring up just in case you don't see Quixel Bridge. Now let's open up Quixel Bridge and let's go over a simple example of bringing in a 3D object. So to bring in a 3D object is pretty simple. Number one, you want to find a 3D object that you like. So maybe this rock right here. Then all I have to do is select this rock and let me make my screen window just a little bit smaller. Hold down the left mouse button and drag it into your world, just like if it's an asset from the content browser. And now we have our rock in our world. Importing realistic assets into Unreal Engine have never been this easy. And if I press Ctrl and Space, we can see in our content folder that 2 new folders were created, specifically Megascans and MS Presets. So Megascans contains all our Megascan assets that we get from Bridge. For example, we have a folder called 3D Assets, and inside 3D Assets, we have another folder called Mossy Forest Rock. And right here are all the assets that make up specifically this rock right here. Now, the other folder, if we go back to content, right next to Megascans is MS Presets. So MS Presets contains all the master materials that Quixel Bridge uses. So if we go out into content, back to Megascans, 3D Assets, Mossy Forest Rock, we'll see that the material that's using is a material instance. So it's not a material by itself. If I scroll down to the material instance, we can see what its master material is, and it's using m_ms default fuzz material. And if I click on the magnifying glass, it's going to jump to its location, which is of course under MS Presets, which contains all those master materials. And you'll also notice that we do get a bunch of parameters. So we're going to go over all the main material parameters that Quixel Bridge provides to us, which we will use consistently. So to begin, let's go over albedo controls. And I'm going to move my window off to the side so we can better see our assets. So albedo tint does exactly what the color tint does that we just created for our own master material. So I can completely change the color of my asset. I'm going to press cancel since I don't want to make any changes to my color right now. And below that is albedo controls. Now we don't see any albedo controls right now since I need to click on the triangle icon to get a drop down. So right here we have saturation, brightness, and contrast, and they all do exactly as you would expect. Saturation increases the saturation of our asset, bring it back to its default value of 1. Brightness controls how bright the asset is. And this is probably the parameter I use the most with Megascan assets, especially if I'm trying to get a lot of different assets to blend together well. I'm going to try to control their brightness to make sure they all have a similar value to each other. And below that is contrast. And all of these have a default value of 1. Now below that is metallic. Generally, I don't have to play with it because this asset isn't metallic. But if you do want to override one of the metallic behaviors, for example, increase the base metallic from 0, which is what it should be since this asset is a metallic, to 1, and then bring metallic map override to 0. Now we can see that the asset is metallic, although I wouldn't recommend you to do it, but it is good to know that those options are there. So I'm going to reset them to their default value. And then below that is roughness. So roughness controls how shiny the asset is, exactly what we learned about during the PBR section of the material chapter. So max roughness is at 1. If I bring this to 0, then the rocks have no roughness and are really shiny. I'm going to bring back the roughness by setting it back to 1. Below that is normal strength, which is like the flattened normal. Although now if we increase normal strength, the normal increases, and then if we decrease this to 0, then the normal map has no effect on our assets. So obviously we do want to leave this at 1, so the normal map has a little bit of an effect. So there's still a bunch of other parameters that we could play with, but these are all the main ones that are needed for props just like this. Now, let's go over how we import a surface material, which is different from a prop, since surfaces are good for a floor like this cube, and not necessarily meant for specific props. So let's go into Quixel Bridge, and let's find a nice surface. For example, brick, decorative brick wall, and we could click download, although I do want to go over the different quality options. So right now it's set to highest quality. We have low, medium, high, and highest. Low quality is 1K textures, medium quality is 2K, high quality is 4K, and highest quality is 8K. So I think generally, unless you're really trying to go for the best looking render as possible, I wouldn't go with 8K textures. The highest I would go with is 4K, and click download. So you're going to have to wait for this to download. And once it is done downloading, simply click the add button. Immediately, we will see that our content browser opens up and we get our material right there. The material functions like any other material. You can drag it and let go to place it on an object. So now we have our brick in our world. I can select this brick and open up its material instance to see what parameters we have, and the parameters are pretty much exactly the same as beforehand, except I want to point out what global does. So global controls our tiling. If I click on tiling offset and then click on the drop down, we see tiling X and tiling Y. If I want to tile it more on the X direction, I can increase this. If I want to tile it more on the Y direction, I can increase this, or I can decrease the tiling in the X and Y to make our texture larger. I can even offset it, so move this texture in the X or Y axis of our object's texture UVs. And if you really want to, we even have the ability to rotate this, although I'm just going to leave it at 0. If you ever want to reset all the values at once, then click on the top arrow. And here is a neat trick that I do want to point out. Let's say you want to go to the folder that this asset is located in, but you don't want to have to navigate to that folder manually, go through all your content folders, and try to find where this asset is located. Well, what you could do is in the details panel, click on the magnifying glass right next to that object, which will jump to that location, or the shortcut is to press Ctrl and B at the same time to jump to that object's location. So if you select any object, for example, the human reference, press Ctrl B, it's going to jump to that location. So that is a shortcut that we will be using a lot, especially when we're creating our medieval village. Now I think is a good time to go over the foliage mode. And to go into foliage mode, simply switch from select mode below landscape to foliage. So foliage mode is great because it allows us to paint foliage around our world very quickly and populate our world with grass, trees, rocks, and pretty much all the small assets you would expect to be in an environment. Now I'm going to press Shift 1 to get out of foliage mode because we first need foliage. And where are we going to get our foliage? Hopefully you could guess, Quixel Bridge. So in Quixel Bridge, come to 3D plants, and we have a bunch of plants to select from. I specifically want to find fern, just as an example, although you could pick any of the plants that are available to us. And I'm going to select common fern. Now, just like when we were downloading the materials, we have different quality options. So I could use low quality, which is 1K, medium quality 2K, or high quality, which is 4K. And I'm going to stick to high quality right now. Let's download it. And once it's done downloading, add to your project with the add button. And now this fern plant is successfully inside of our project. I can drag this out to see exactly what assets were made available to us. Unlike other Megascan assets, foliage can have multiple objects. So here we have 3 different ferns, and let's open up the material instance to see what options are available to us. We have a couple ways to open up our foliage's material instance. Number 1, I could go into the details panel with any of these selected and select the first material available to us, or I can press Ctrl and B to jump to that object's location, which is our fern folder, and select the material right here. I want to make sure that I select the material that doesn't have billboard inside of it. So select the non-billboard one, and this will be our main material instance. So I'm going to go over all the main parameters of foliage. So first off, we have color overlay, which is essentially functions just like our color tints. So if I want to make my foliage a little bit blue or red, this is where I make that change. And when I do make it red, it kind of gives it a fall feel, which is pretty neat. Press cancel since I don't want to make those changes. And right above that is color variation. Because you wouldn't expect each fern to be the same exact color. There would be a little bit of variation between all the different ferns, and that's exactly what color variation does. If I bring this up to something large like 0.5, notice how each fern has its own individual tint. Now normally you don't want it to be this intense. You'd want it to be just a little bit like 0.1 or even 0.05. So that there's just a little bit of variation between all the objects. And below that is roughness intensity. So roughness intensity is just like our master material's roughness strength. So bringing it down to 0 means our object is very shiny, and bringing it up to, let's go, 5, will make our ferns pretty rough. Let's leave it as default value of 1. And below that is normal intensity, which functions like normal strength. Bringing it to 0 gets rid of the normal maps. So this is with the normal maps and this is without. Or bringing it to 5 gives ourselves really intense normal maps. But I'm going to leave it at 1 for now, which is its default. And after that, we have translucency, strength, and desaturation. So light doesn't just stop when it hits a leaf. Instead, light goes into the leaf, it bounces around a little bit, and then it leaves the leaf. So that is where translucency comes in. Translucency is how much light should bounce around inside the leaf. It's at a value of 7. If I bring this to 0, then we have no light bouncing within the leaf. If I bring it up to 1, then a little bit, 2, a little bit more, 5, and finally the default of 7. And below that is translucency desaturation. Notice how if I bring it down to 0, then it becomes completely desaturated. Now the light inside the leaf is white. Or if I bring it to 1, then there was no desaturation when the light was bouncing in the leaf. So I'm going to leave it at the default value of 0.95. And finally, we have probably the most important parameter, and that is enable grass wind. So turn this on and then set it to true. So now our plants have wind, which adds a whole nother level of realism. We can control the wind intensity by, of course, playing with it right here. So if I bring it to 0, then there is no wind, and its default is 0.15. Maybe if we're inside a hurricane, make this 0.5, and now it's super intense. So I think 0.15 is a little bit too intense by default, so I'm going to bring this down to 0.05 for just some really faint movement. Now you probably notice throughout this entire time is that the foliage pops a little bit as I go further away or closer up to it. And this popping is level of detail. So we can better see level of detail by opening up the foliage in its static mesh editor. And right here, we have LOD. LOD 0 is what the foliage will look like when you're really up close to it. And actually, let me go uncheck the grid so we can better see this. LOD 1 is what it will look like when we get a little bit further away. When the camera gets even further, we go LOD 2, further LOD 3, and finally we go to LOD 4. And as we increase LODs, as the camera gets further and further away, we lose more and more geometry. Until we get this weird thing right here, which is essentially just a picture of the fern, which is pointing at the camera. So this material right here is what the billboard is. So that's why we weren't editing this material, since this material is completely different from our main material instance. If we did edit this, then we wouldn't see any changes right now in our world, since we're zoomed up pretty close to our ferns. We would notice a change if we're far away, and hopefully you can see it in YouTube. all of our ferns just transition to a billboard, which is the furthest LOD possible. So that's important to point out that if you do make a major change to these ferns, for example, let's give them a color tint of blue. We have blue ferns, but if we go away, our billboards are green. So we also have to go into the billboard material instance, which is the second material, and change this color to blue to match the main material instance. So we get a better transition. Now, that looks terrible, so I'm going to change it back to its default value of gray, and right here, change it also back to gray. And I can exit out of all of these and save everything, because now that we've gone over the material parameters for foliage, we can talk about the foliage mode editor, which we can open with the shortcut Shift 3. Right here is where we get all the assets that I want to paint onto our landscape. We can see that it was already auto-populated by the foliage that we downloaded from Megascans. The reason why is because Unreal is smart enough and Megascans is smart enough to know that if we're downloading foliage, odds are we want to paint it. Now, if we don't have anything right here, then we could drag any 3D object into the foliage editor by just selecting them in the content drawer, hovering over, and adding them as a foliage type. Now, I'm not going to add them as a foliage type because they're already added right here. So if I select any of them, we see that I get a details panel down here with a bunch of options for how I want to paint this specific object. Now, if you do not see these options, that's because you have to come up here and make sure this button is blue. So to start painting, make sure you have paint selected, and you'll notice that nothing is happening. That's because I need to activate right here what foliage I want to paint down. So I need to tell Unreal exactly what assets I want to paint. So for example, if I just want to paint this asset right here, then hover over the assets icon, and in the top left hand corner, make sure it's turned on. So now this is going to glow while all the other ones are a little bit darker, and that tells me that I can paint it. So come to paint, and now hold down left mouse button, and I'm painting this foliage around. And wait a little bit for the shaders to compile. If I want to paint all three, then make sure all three of them are activated. So now I'm painting a lot of them down. If I ever want to get rid of these or erase a specific foliage type, make sure that foliage type is selected and hold down Shift to erase them. So it is pretty simple. I can decrease the brush size by coming up here, or I can use the shortcuts from the landscape mode, which are the left bracket key to decrease brush size and right bracket key to increase the brush size. I even have access to paint density. So right now it's at 0.5. If I want to paint down more foliage, then I can increase this to 1 and I'm painting a lot more. Or if I don't really want to paint that much down, then set it to 0.1. I'm just going to paint a little bit. Hold down Shift, and I can always erase everything that I've already done. And of course, if you don't want to paint a specific foliage type, just make sure you have that unchecked. And now we're only going to paint this one and this one. So if you want to quickly select all the foliage types, then you can press Ctrl and A to select all. So in Unreal Engine, Ctrl A is select all. And then in the top left hand corner, you can uncheck it to uncheck them all, and then check it again to check them all. So that's a nice shortcut. And you can also hold down Ctrl to select multiple objects, or you can hold Shift to select objects in a row. So now that I have them all selected, I want to edit the properties down here, but I want to edit the properties all at once. So I'm going to press Ctrl and A to select all of them, and we have density down here. Bring paint density all the way up to 1. And we can see that, yeah, this is pretty dense, but what if I want this to be even more dense? Well, down here for density, I can increase this from 100 to 200. So this should be twice as dense. We can see that's already pretty dense. Even take this up another notch to 500. And now we are going to be painting in a lot of ferns. But these ferns still look a little bit unrealistic. And there's two reasons. Number one, I think the variation of our ferns is a bit too much. So let's jump back into our material instance. And for color variation, I'm going to lower that from 0.05 to 0.01. Okay, so that's better. But all the ferns have the same exact size. And plants never have the same exact size. Normally they have different sizes depending on where they're placed or how old they are in their lifespan. So let's jump back into foliage mode with Shift and 3 and select all of them. Now I'm going to delete them all. Scroll down, and for scale X, let's have a random range for each time we paint the foliage from 0.5 to a max of 2. So now if I paint, and actually hold down Shift, decrease the density from 500 to 100 so we can better see each individual fern, we will see that we have a very wide range of sizes. So some ferns are small, and some ferns are larger than the other ones. Also, if you enjoy placing assets by painting them, but let's say, for example, there's one asset and you don't like where it's placed, but you don't want to delete all the assets that are around it, well, instead of using paint, you can use select, and then you can grab that individually and move it away. So you can still move individual objects and even scale them and rotate them despite using the paint mode. So just keep that in mind that you still have a lot of control over the placement of your objects. And it's also important to point out that, let's say, for example, I'm painting and I only want to paint on my landscape, and then I go on top of a mesh, and then I start painting on top of my mesh by default. Also, when I now move this mesh around, we can see that that foliage is stuck to that mesh. So if you do not want that to happen, I'm going to press Ctrl and Z to get rid of that. Press Shift 3. Make sure under filters that static meshes is turned off. So now when I'm painting, I'm only painting on top of my landscapes and not on top of the static meshes. So that's the very basics of foliage in Unreal Engine 5. We're going to be painting a lot of foliage when it comes to our final environment build towards the end of this video. Now it's time to talk about one of the main features of UE5, and that is Nanite geometry. So Nanite geometry is a brand new way of rendering geometry that allows for a near infinite amount of source polygons on our screen at any time. So this means we could get high quality movie assets rendering in real time, which wasn't possible beforehand. And now I know that might sound a little bit too good to be true, so I have two examples we're going to jump into to demonstrate the power of Nanite. Right now I have the Unreal Engine 5 demo project downloaded. You could download this project within the Epic Games launcher under samples, and it's called Valley of the Ancients. So if you want to check this out, then you could download it right now. Although do keep in mind that this project is 100 gigabytes large, since we're using really dense models, because Nanite allows us to do that. So this entire desert is made possible with Nanite. And we can see Nanite in action by coming up to Lit, down here to Nanite Visualization, and selecting triangles. So every color you see is an individual triangle, is an individual polygon. And notice how when I zoom in on any of these rocks or cliffs, our triangles get denser and denser as I zoom in, and when I zoom out, the triangles get larger and larger. So this is all possible due to Nanite. Beforehand in Unreal Engine 4, using geometry that is this dense was not possible. Now do keep in mind that at the time of recording this video, Nanite only works for solid static meshes that do not deform. So for example, it works for rocks or for cliffs, but it doesn't work for foliage. Epic Games is aware of this issue and they're right now working on it. So maybe if you're watching this in the future, then Nanite works for grass and trees. But for now, it only works for solid static meshes. And another cool feature of Nanite, specifically for this sample project, is that, and if I increase my camera speed, there is no landscapes whatsoever. Everything you see right here is a Nanite static mesh. So the ground is not a landscape, it's a collection of static meshes that are layered on top of each other to make it look like the ground is one landscape. So here's another example demonstrating Nanite. So right in front of you is a donut I made in Unreal Engine, and this donut is made up of about 30,000 different polygons. Here we have that same donut, but copy and pasted over 100,000 times. And as we can see, my frame rate is about 5 to 10 frames per second, which is obviously unplayable. And the reason why is because these donuts aren't making use of Nanite. So to enable Nanite on any static mesh, simply find where that static mesh is within the content drawer. As a reminder, a shortcut is to select that static mesh and press Ctrl and B to jump to its location. And to activate Nanite, right click on the static mesh, come up to Nanite, and select Enabled. So it is that easy to enable Nanite. And now here's that same environment, but all the donuts are Nanite. And we're hovering around 40 to 60 frames per second. So we went from 10 all the way up to 60 frames per second, which is amazing. We can even come up to lit, Nanite visualization, and select triangles to double check that this is all using Nanite geometry. So I finally jumped back into our first project. And as a reminder, to enable Nanite, all you have to do is select the static mesh, press Ctrl and B to find out where that static mesh is within your content drawer, and right click and select enabled. Now Nanite is enabled for this asset. Here's a tip: we can see what assets have Nanite enabled by coming up to lit, Nanite visualization, and instead of clicking on triangles, which has been showing us how many polys are on a mesh, we can select mask. So everything that's green is using Nanite, and everything that is red is not using Nanite. As a reminder, at the time of recording this video, Nanite only works for solid static meshes, like the rock right here. It doesn't work for foliage, although that will be changing. So maybe in the future, you can enable Nanite on foliage and make that a lot more performant than what it is right now. We can even download a Nanite version of this object. So Nanite will automatically be enabled from Megascans. To do so, let's hop back into Quixel Bridge. And I specifically want to download, let's go Nordic Formation. Type that in, and I think it is this mesh right here. So Nordic Beach Formation. And instead of selecting high quality, medium quality, or low quality, we will select Nanite quality and click on download. Now this will take a while since Nanite quality is downloading the best quality possible, which is a very, very high resolution mesh. And now that's downloaded, click on add. So a new window will pop up with your mesh. So I'm going to exit out of bridge and drag this out into my world. It might take a while for all the shaders to compile. And we have a Nanite mesh. We can see how dense this mesh is by going into wireframe view mode with Alt and 2. So this is how dense a Nanite mesh is. Compare this to downloading a mesh at medium quality, like these rocks right here, compared to Nanite quality. Obviously, Nanite is a lot better. We get all this small detail within the rocks, which really helps make it realistic. The only issue is since we're downloading 8K textures and a high resolution mesh, it's going to take up a lot of disk space. But if you're not worried about large project files, then I would download everything as Nanite, since there is no performance cost, and in a lot of cases, it's actually more performant to use Nanite meshes than non-Nanite meshes. So here's what we're going to do, is that I want to compare all the different quality types that we're able to download from Megascans. So I'm going to jump back into Quixel Bridge and download this same asset, but download the low quality, medium quality, and high quality to compare them all. So here are all the different qualities for this asset. And to better see the difference between them, I'm going to press Alt and 2 to go into wireframe view mode. And our landscape is right now interfering with us analyzing the wireframes of our assets. So I can select the landscape and hide it with H. So H is a shortcut to hide an asset without having to navigate to it within the world outliner and selecting the eye icon. I can also press Ctrl and H to unhide an asset. So click on it, press H to hide it, and Ctrl H to unhide it. So I'm going to leave that hidden. And over here we have the lowest quality. It's pretty noticeable that there's not that many polygons on this asset. And the shadows from our directional light make it very noticeable that this asset is pretty low poly. Now right next to it is medium quality. So medium quality has a little bit more polys and it's at 2K while low quality was at 1K. And next to that is high quality. So high quality obviously has a lot more polys and the textures are also at 4K. And finally we get Nanite with 8K textures and the highest poly count possible. So this is the source poly counts that are directly from the scan. These are the kind of assets you would see in movies, not in video games. But because Nanite is enabled, we are able to use them in our project. So those are the different quality selectors. One thing I do want to point out is that notice if we pay attention to our high quality asset, as I zoom out, the polygons shift until I'm so far out that basically these three assets are using the same amount of polygons. That's because Megascan assets, when not using Nanite, use level of detail. So press Ctrl and H to unhide the landscape, and I can open up my asset by pressing Ctrl and B to jump to that asset's location in the content drawer, and then double clicking on the asset to open up the static mesh editor. Or as a shortcut, instead of having to navigate to that asset's location in the content browser, I can press Control and E to open it up. So make sure you have any asset selected, for example, the medium quality one, and press Control and E to open up that specific asset. Now I'm going to dock it up here so I get a better look at my static mesh. If I press Alt and 2 to go into wireframe view mode, zoom in, we see that this is the asset's highest poly version, and as the camera zooms away, it slowly starts to transition into lower and lower LODs. And we can see each of these individual LODs up here. So LOD 0 is the highest one, 1 is lower, 2 is even lower, and finally 3 is the lowest. So this is how we used to make our assets more performant back before Nanite. But since Nanite does exist, there really is no reason why I can select all 3 of my static meshes, press Ctrl and B to select all of them in the content drawer, right click, and enable Nanite. So save everything, and pressing Alt and 2, you see that we no longer get level of detail, but what we do have is automatic level of detail that's being generated from Nanite. So even when you have very low poly meshes, it's still recommended that you enable Nanite. Now it's time to start programming in UE5. And in case you forgot, Unreal Engine is a video game engine. So of course programming is going to be a pretty big part of it. But Unreal Engine handles programming a little bit differently compared to other video game engines. Instead of having lines of code we write to tell the engine what to do, we instead have blocks of nodes. And we connect these nodes to each other to create logic. These nodes in Unreal Engine are called blueprints, and blueprints is Unreal's visual scripting language. Now, in my opinion, blueprints are a lot easier and a lot faster than traditional ways of coding, like in Unreal Engine, where we would have to type everything out using C++. Even if you don't plan on programming anything, I still highly recommend that you learn blueprints because blueprints is literally everywhere inside the engine. It's what we use to connect the different parts of the engine to each other. So it's an essential skill to know if you do want to learn Unreal Engine. And with all that being said, let's learn blueprints by creating our first video game in UE5. To begin, before we do anything, let's duplicate the current level we have open and create our game within our new duplicated level. So if we come up to the top left hand corner, we can see the name of our level, which is called Landscape Example. If you remember, we created it within My Stuff and Maps. So since Landscape Example and Landscape Example up there have the same exact name, that means that this level is the level we currently have opened. So I'm going to select that level and press Ctrl and D at the same time to duplicate. Now it's going to ask for a new name. I'm going to call this one Game Map. Now we can rename any assets within the content drawer by right clicking and going to rename. Also the shortcut is FN2. But I like the current name, so I'm not going to do that. Now I'm going to double click and save selected to open up our new level. And here we have the map we will be editing to create our very first game. So to play a game in Unreal Engine, click the play button up here in the toolbar. So pressing it, we'll start playing our game, but we can't control our game right now since I need to click into the viewport, and now I get full control over the game. So I can press the escape key to stop playing my game. So to play a game, click the play icon, and to control the game, click into the viewport. We don't have our mouse anymore, and that's because to stop playing, you need to click on the escape key. So you probably noticed that our controls for our game were pretty basic, since it's just the WASD keys, just like the viewport controls. And that's because we don't have any characters or gameplay elements set up yet. So in order to set up a gameplay element, we first need access to the world settings. Right now we don't have any world settings tab. As a reminder, to get the world settings window, come up to Windows and select world settings, and now we're going to get a brand new window right here, which we can switch in between details and world settings. So right here we have game mode override. This is where we set exactly what game we want to play. And at the drop down, we should have BP underscore third person game mode. Now, if you don't have BP underscore third person game mode, that's because you didn't add the third person content yet, which is the content that includes this character right here. So if you want to get our character and our game mode, press Control Space, go to Add, and Add Feature or Content Pack. And select third person, then click on Add to Project. Now I've already done that, which is why I get BP underscore third person game mode, which is located under one of the files that were created when I added in the third person content under third person and blueprints. So it's this one right here. Alternatively, instead of selecting it from the drop-down, I can also hold down the left mouse button and drag it onto it and let go. So now if I press play, we see that we get a third-person character. I can use the WASD keys to move around, space to jump, and the mouse to rotate my camera around my character. And as a reminder, I can press the escape key to get out. Alternatively, as a shortcut, instead of coming up to my toolbar and pressing the play button, I can press Alt and P to automatically play my game. So that's Alt and P to start playing my game without having to come up to the toolbar. And also notice how when I do click into my viewport, I no longer get access to the mouse cursor. If I ever want to get back the mouse cursor while playing my game, I could press Shift and F1 at the same time. So that's Shift F1 to bring back my mouse cursor. And instead of pressing the escape key, I could come up to the stop button and press that right there to escape my game. So let's open up our first blueprint. And specifically, the blueprint we're going to open up is the character blueprint we're right now controlling. So you can find the character blueprint by coming into third person and selecting blueprints. So it's right next to BP underscore third person game mode. It's BP underscore third person character. So double click on it to open up our first blueprint. Now we're currently on the event graph. Don't worry, we're going to go over what the event graph does in just a bit. But to see all the objects that make up our blueprint, select the viewport. Now, the objects that make up a blueprint are called components. And I can select a component just like on the level editor. Also, just like the level editor, we have the same exact controls. So I hold down the right mouse button to look around and move. And I can select any of the objects, press the F key to focus on it, hold down the Alt and left mouse button to rotate, and Alt and right mouse button to zoom in and out. So this is basically just like our level editor, but for our blueprints. Also, we have the equivalent of a world outliner. So on the top left-hand corner is the Components tab, which contains all the components inside of our blueprint. Just like an object in our world, I can select a component and change its properties in the Details panel. For example, right now we're using skm underscore Quinn as our skeletal mesh, which is the female mesh. If I want to change it, I can select skm underscore Quinn and then select skm underscore Manny to change it to the male one. So now if I play my game, we can see that we have a different body. So now let's jump into the event graph. So the event graph contains all the nodes and blueprints, which makes up the programming or logic behind our third person character. Now, if you don't see an event graph, for example, if it's closed, then you could come into my blueprints and double click on event graph to bring it back. Also, we can move any of the windows just like in the level editor and change things to our liking. Now, if you mess up the user interface to the point of no return, then come up to Window, Load Layout, and Default Editor Layout to reset the windows to what Unreal has by default. We get an extra window under our event graph called Compiler Results. I don't need this, so I could click on the X icon, or as a shortcut, hover over the tab and press the middle mouse button to close it. So let's go over exactly what some of these blueprints do right here. So if I zoom in, for example, on the jump input, we can see exactly the logic that's behind jumping. So the logic is pretty simple. We have an event, which is essentially, at least in this case, functions as a keyboard press. So input action is jump. Right now it's set to the spacebar. So when I press the spacebar, our character jumps. And when I release the spacebar, our character stops jumping. And we can see this in action by clicking on the play button and pressing space. Now notice that I did spawn all the way over here, and that's because we don't have a player start within our world. So to add a player start, come up to the add button, go down to basics, and drag in a player start. So here we have a new object in our world. If I press play, our player starts from this location and also points in the direction of the arrow. So if I rotate this, for example, it's facing the rocks, and press play, now our player starts and spawns right there, pointing at these rocks. So if I jump back into BP underscore third person character and play our game, we start from this location. Now I'm going to press Shift and F1 at the exact same time to get back my mouse cursor, and I'm going to move the window to the top right hand corner so we can see exactly what is happening. So if I press space, we don't see visually what is happening within our event graph. So to see the blueprints running in real time, I could come up to No Debug Object Selected and then select BP underscore third person character spawned. Now, if I zoom out on my event graph, notice how some of the wires turned from white to orange. These orange wires tell us that these nodes are currently being activated. If I zoom back into input action jump, and let's get back our character. If I press the spacebar, we can see that I jump, and then when I let go, we stop jumping. So jump and stop jumping. So this is a great way to debug and watch our logic running in real time, which is amazing, and it really speeds up the process of programming in Unreal. So let's create our first sequence of nodes. We're going to add in new functionality. Specifically, I want to add in the ability where when I press the F key, our character drops and it ragdolls. So we no longer have control over our mesh. Instead, we let the physics take control and watch his body fall over, similar to GTA or other games. So to do so, we first need to add in an event. Specifically, to add in any node to our graph, right click, and we're able to type in the name of the node or manually scroll to that node's location right here. But obviously, there are a lot of nodes since we're able to program an entire game through blueprints. So something I like to do is type in the name. I'm going to type in keyboard because it's under keyboard events, and F since it's the F key, and select it. So now we get a new event that will be fired whenever I press the F key. To double check that this event is working, I'm going to add in another node by right clicking and typing in print string. So to hook up two nodes and connect them to each other, hover over the output, hold down the left mouse button, drag into the input, and let go to connect them up. To break, hold down the Alt key and left mouse button in either the output or the input. So the controls are very similar to our material graph. And now within print string, we see that the string is going to be hello. Instead, I want to say event was fired, exclamation points. And we can get more options for this node by clicking on the drop down at the bottom of the node. And for text color, instead of blue, make this orange. So now, if I press the play button, click into my window to start playing my game. When I press the F key, the event is fired and print string is activated. So when I press F, then we get text onto my screen that says event was fired, which is what we just programmed. So I'm going to escape my game and delete print string, since that was just an example that I want to show, which proves that my event right now is working. So whenever I press the event key, all the nodes that are connected to pressed will be activated. So specifically, I want a new node. Now I could right click and type in the name of the node, which is set collision enabled mesh, and then hook it up like that. Or as a shortcut, I'm going to delete those and drag from pressed, let go, and it will automatically bring up my nodes. Now I can type in set collision enabled, select mesh, and they will automatically be connected. So that's another way to bring in nodes. And notice how this is two nodes. We have set collision enabled, and for target we have mesh. Mesh is a reference to the mesh component of our blueprint. So it's specifically referencing our character right there. Jump back into event graph, and if it's for some reason not hooked up by default, then I can drag mesh from the components window into my event graph, let go, and plug it up like that. But Unreal's smart enough to know that if we do want to set collision enabled, we probably want to do it to the skeletal mesh right here. Now, for new type, instead of no collision, select collision enabled query and physics. Don't worry exactly what this node does. I'm going to show what it does in just a moment. Now I want to connect another node from set collision enabled, which is set simulate physics, and specifically choose mesh, which will automatically connect our mesh to this new node. Make sure set simulate physics is turned on. Drag from here again and go set physics blend weight, and then select mesh. And for the blend weight, change it from 0 to 1. So as you can probably guess, these three nodes will essentially ragdoll our character. Pressing play again, I can run around my world, and then as soon as I press the F key, our character ragdolls and the physics take control. So let's do that again. I can run around, jump, and press the F key to ragdoll. We can better organize our graph Because notice that the target for all 3 of my nodes is mesh. So we don't have to drag from an individual reference to mesh. We only need one reference to mesh. So I'm going to select these 2, delete them, and drag out mesh into set simulate physics, and drag from the same one to set physics blend weight. I can also better organize my graph by hovering over any wires and double clicking to add in a reroute node. So simply hover over a wire, double click to bring in a reroute node, which doesn't change any of the logic. It just helps better organize our graph. And hold down Alt. So I'm going to break this connection and then drag from the reroute node into set physics blend weight, hover over the wire, double click, and bring that down like that to just better organize my graph. Now I can watch all 3 of them be enabled by clicking the play button. And let me go make my window just a little bit smaller. Make sure that BP underscore third person character is selected as the debug option. And when I press F, we can see all 3 of those nodes are activated, and it gives us this ragdoll effect. Okay, so let's create a little obstacle course for our character. Jump back into game map, and I want to create an elevated area where the obstacle course will be. So press Shift and 2 to go to landscape mode. Have sculpt selected, and it's not that intense. So bring tool strength up to 1. And I'm going to keep sculpting until I find a height that I like. For example, right here is pretty good. Go into the flatten brush, and then hover over the exact height that you want. Hold down the left mouse button to flatten that. So now I can create a little obstacle course area right here like that. And I think the edges are too sharp. So I can also go into smooth, bring down the tool strength, and slightly smooth out the area. So maybe even a little bit less strong, just so that we don't get any artifacts from those sharp angles. And I could select my player start and drag it all the way up here, or I can delete it and let's add in a brand new one. Come up to add, basics, player start, drag it in, and make sure it's pointing in the X direction. So now if I press play, our player starts right here, and they're going to have to navigate some obstacles until they get to the very end, and they win the game. So this is going to be the quickest and worst game made in history. So let's create our obstacle. And this obstacle is specifically going to be a blueprint. So press Ctrl Space, and let's create the blueprint under third person blueprints. Right click, and under create basic asset, select blueprint. And I want it to be an actor. So this name is going to be BP underscore obstacle. And you might be wondering, why do I use BP underscore? Well, BP stands for blueprint, and it's just naming convention. You could name this obstacle without the BP, but I like to include it. So double click to go inside of our blueprint. And this is what a completely empty blueprint looks like. So let's actually add in a new component, which will be our obstacle. So come to add, and down to here, select cylinder. I want to decrease its width just a little bit, and also increase it a lot in the Z axis. So I'm going to move this up so that the bottom is touching the grid floor, and come back into game map. Let's go find where the obstacle is and drag it into our world. Also, it's recommended that you do press compile, which will set all the changes we made in the blueprint, but all blueprints will automatically be compiled when we press play. So come back into game map, press play, and here we have our first obstacle, and I want it where when the player touches it, he ragdolls, and we essentially die. So let's come back into our obstacle, and I need to add in a collision volume. So type in collision, and it's going to be a capsule collision. So select that right there, and I'm going to scale up this collision. So let's scale it up, and make sure that the collision is larger than the cylinder. Because otherwise, if the collision is too small, for example, if it's smaller than the cylinder, then our character will collide with the cylinder first and never collide with the actual collision volume. So make sure that is a little bit larger than it is. And then in the details panel with collision selected, you want to select on component begin overlap. So this will be called whenever our collision comes into contact with an object. But right now, this event will be fired whenever it comes into contact with anything. So if it touches a plant, or maybe if we have birds in a game, it touches a bird, then this event will be fired, which is something that we don't want to happen. So we can get around that by dragging from overlapped other actor and doing cast to BP underscore third person character and select that. So essentially what this casting is doing is that it's going to check if the overlapped object is a third person character. And then if it is, let's print string to double check that this is working. And for the string, say collided with character. So let's jump back into game map, press play. And now if I come up to it, we see top left-hand corner right here that we are colliding with the character, which is something we want. Now, I want it where when we do collide, our player ragdolls and dies. So jump back into BP underscore obstacle. Let's delete that. And casting also has the benefit that we get access to a lot of the properties that are within BP underscore third person character. So if we jump back into our character, I want to create a custom event right here. So this custom event will allow us to call all the nodes that we've already set up. So right click, type in custom event, and call this one death, just like that, and drag it into the start. So make sure you compile, because otherwise you will not see it. But if we jump into BP underscore obstacle and drag from our third person character, we now get access to the death event. So select it. We can now control when our player dies from another blueprint, which isn't our third person character. F was just being used as a debug event. I'm going to delete it because all we need is the death function. So if I press play now, if the player now collides with the obstacle, we see that as soon as I touch it, our player dies. So let's go do that again. Come to the obstacle, touch it, and he dies. So what's happening right now is that in BP underscore obstacle, as soon as the object touches the capsule collision, it's going to check if that object is a third person character. If it is a third person character, then we're going to call the custom event called death. Double click on the event to jump to where it's being created, which is in our third person character, and all these nodes ragdoll our character. Right now our obstacle isn't much of an obstacle. If I press play, it's very easy to avoid this pillar, since this pillar isn't moving. Now we can make this a little bit harder by adding rotation to the pillar. So let's jump back into BP underscore obstacle, and I'm going to specifically use the event tick. Now by default, every new blueprint does include an event tick right here, but in case you deleted the default events, you can always get back the event tick by right clicking and typing in event tick and selecting it. So the event tick is pretty unique compared to other events in that it runs every single frame. So we can see this running in action by adding in a print string, and for the string, call this one activated. So now if I press play, we can see that every single frame activated is being called. So let's go delete that. And I want to use the node called add actor local rotation and select it right there. So plug it up like this, and we're not going to notice anything happening since we need to add a new local rotation. And I specifically want to increase, let's go the x-axis 5 degrees. So now if I press play, we see that every single frame, my obstacle is rotating 5 degrees. And while this is great, there's one issue, and that is it's frame dependent. So right now we're running at probably a smooth 120 frames per second. But what if this game was running on a computer that's not as powerful and it's running every 30 frames per second? Well, we can see what it's like to simulate that by pressing the backtick key to bring up the command line and type in t.max FPS and type in 30 to lock it to 30 frames per second. It's still rotating 5 degrees every frame, but we have less frames, so it's going to be rotating slower. So we need to make this frame independent. I can bring back my original frame rate by clicking on the backtick key again, typing in t.max FPS, and put in 0 to uncap the frame rate. And to do so, we need to use the delta seconds. So I'm going to drag from delta rotation and type in make rotator down here. So select that, and essentially the make rotator will break our rotation. So we get access to X, Y, and Z independently as inputs. So I'm going to drag from delta seconds and type in multiply like that and select it. So now the output will go into the X. And for rotation, we're going to set it back to 5. So if I press play again, and now we're going pretty slow, so I'm going to increase this from 5 to 100. Press play again. And our obstacle is rotating. I can lock this frame rate by clicking on the backtick key and type in t.maxfps. Let's lock it to 30. And notice that despite it being 30 seconds, we're still rotating at the same exact speed as beforehand. I can even try t.maxfps, 120 frames per second, and we have the same speed. So our gameplay is no longer tied to our frame rate, which is exactly what we want. Right now, all we have is one obstacle blueprint in our world. If I want multiple of them, I can select this blueprint and hold down Alt to duplicate it, or I can drag it out from our content drawer. Now, if I press play, we do have the issue, and that is they're rotating in the exact same direction. I can rotate each of these blueprints in a random direction on the Z-axis to give our rotations a little bit of variety. Now, if I press play, we're rotating in different directions, but it's pretty hard to tell exactly what direction it's going to be rotating on when editing our game in Viewport. To help us know the direction that we're rotating, jump back into BP_obstacle. Let's go to Viewport and click on add, and we're going to add in an arrow component. So this arrow component, and I can zoom in to see exactly what it is, it will not be visible when we're playing our game, which is exactly what we want. So for arrow color, I'm going to set this to blue and also rotate this. Let's go 90 degrees in the Z-axis and lift this up. So now if I compile, jump back into game map, we can see that I have a blue arrow that's pointing in the direction that my obstacle will rotate. So pressing play, I'm able to tell exactly where this object will rotate to. Now that I do have some obstacles, there's just one issue, and that is they're all going the same exact speed. I want some obstacles to be slower than others. So I want to be able to edit that property in the details panel of the blueprint. So to do so, I need to make a variable. And variables are pretty similar to a materials parameters. So let's jump back into event graph. And under variables, I can create a new one by clicking on the plus icon. So call this one rotation speed. And instead of Boolean, I can change it up here to a float. So a float is a number with decimal points. Now I can hold down the left mouse button and drag out rotation speed, let go inside of my event graph. And it's going to ask me whether I want to get it or set it. I want to get the rotation speed and plug it up right there. So instead of 100, we're going to be using whatever value is stored within the rotation speed. So you can essentially think of variables as containers of data. Now, when we do have rotation speed selected, we're unable to change that value because our blueprint needs to be compiled. So as soon as I press compile, I now get access to that value. It's set at 0, so if I do play my game, we aren't rotating. Now I can bring this back to 100. And if I play my game, we have the same exact speed. But that's not the point of variables. Variables are great because they allow us to change the default value. So I want to expose this variable. That's how I'm able to edit it within the details panel of my object. Make sure that you have rotation selected, and in the details panel, check instance editable and expose on spawn. Now if I press compile, jump back into game map, we can see that when I do have an obstacle blueprint selected, rotation speed is made available. So I can make this obstacle right here have a speed of 50, this one a speed of 200, and right there, let's go 300. Now, if I press play, they all have different speeds. So it makes it a lot harder to try and navigate this obstacle course. We are right now missing a very crucial element to our game, and that is an end goal. So the goal that I want the player to try to reach is specifically under starter content, props, SM_statue. So the player is trying to make it to the statue, and I'm going to change the material from glass to gold. So starter content, materials, and drag metal gold onto the glass like that. Now, when the player, and I'm aware that you can just walk around the obstacle course, I want to add in the feature where when the player is by the statue, we get a windscreen telling us that we did beat the game. To begin, let's add in a trigger volume, which will trigger whenever the player is near the statue. So to do so, come up to Add, and under Volumes, select the trigger volume. So I'm going to drag it out and place it so that it's around the statue. We want to program it where whenever the player collides with this trigger volume, then a windscreen will pop up. We're going to program this logic through the level blueprints. So every level in Unreal Engine has its very own blueprint, where we're able to script logic that is very specific to the level. So to open up your level blueprint, come up to the blueprint icon right here, select that, and then select Open Level Blueprint. Now this is the event graph that is specific for Game Map. We can even see that the name of this blueprint is Game Map, which is different from BP_obstacle or our third-person character, since it's not an individual object, instead it's the level as a whole. Now, I'm going to delete our default custom events, and I want to make sure that in my level editor, I have the trigger volume selected. So with it selected, I'm able to get a bunch of different properties and events that are related to the trigger volume. For example, if I right click, we can see that add event for trigger volume 3, and under collision, we get the event that I want, which is add on actor begin overlap. If you do not see any of these options, then you want to make sure that you do have your trigger volume selected in the map. So right click, add event for trigger volume collisions, and add on actor begin overlap, which is essentially a very similar event to our on component begin overlap. So we want to do the exact same thing we did right here, and that is make sure that we are overlapping with the third person character. So drag from other actor and cast to third person character and select it right there. Now I want to make sure that this event is working by dragging from this node and printing string. So the sentence that I want to come up is "You won the game!" exclamation point. So ideally, pressing play, I'm going to walk around my obstacle course. We will fix that in a bit. And as soon as I come into contact with the trigger volume, we see in the top left-hand corner, we get the string, "You won the game." Now let's create a windscreen. So to create a user interface, let's press Control and space. And I'm going to create it under third person blueprints. Right click, under user interface, select widget. So user interfaces in Unreal are called widgets. And I'm going to select user widget under common. Now it's going to ask me to name this widget. I'm going to call this one win screen widget, and then double click to go inside of it. So this will be very brief. It's not a proper introduction to the widget editor, since all I want is a little bit of text that will come up once we do beat the game. So to begin, in the palette, I'm going to type in canvas and drag in canvas into my graph, let go. The green outline is essentially our window. Now I'm going to type in text and drag in text into my graph. So I want to center my text. That's what's in the middle of my screen. And then in the details panel, let's go change the text to "You won the game!" exclamation point. Also under appearance, click on the font drop down and increase the size. So the text is very noticeable. I'm actually going to decrease it just a little bit more. And I want to move this flower icon into the middle of the screen. That's how my text is anchored. So my text will always be in the middle of the screen, no matter the size of my window. So press compile and let's save everything. Now jump back into game map and I'm going to delete this print string since now we have a proper windscreen. Drag from here and create a widget. Of course, the widget we're going to create is the one that we just made. So windscreen widget, and drag from here, then add to viewport. Since by default, it will be hidden, we need to show it. So now, if I play my game, go around my obstacle course, and I collide with the collision of my statue, we see that I just won the game. And congratulations, you just made your first video game in Unreal Engine 5. While it's not the best, hopefully you did learn the very basics to programming using blueprints. Real quickly, let's fix the game so our player can't run around the obstacle course. So press Shift 2 to go back into landscape editing mode, select flatten, and flatten it out so the player only has one direction or one way to go to get to the statue. And also select all the obstacles, hold down Alt, and I'm going to rotate them around and move them like this. So there are multiple objects the player has to dodge. And I'm going to delete one of the obstacles in the middle to make our game a little bit easier. And move the player start. Since if I press play, I just get dropped from the play space. Move the player start so it's resting on top of the landscape. Press play. And now the goal is to try to make it past all the obstacles and not get hit.